For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
Okay, looks like we are live, guys. We are going to start. We've got Brother Will here as well as Brother Neff. Actually, it looked like he just...
We lost Neff.
But he is back. Okay, so good to have him. So anyways, guys, thanks for your patience. Doki Doki Bible Club already winning the Super Sticker War. You have bought Neff and I a coffee for tonight, so it'll keep us going all night long. And Will, you're too young for coffee, brother. So
I got some Red Bull.
If you drink too much coffee, your babies come out naked and upside down. So I don't want you to...
They're devolving.
Yeah, I know. I stole that from Hovind. So speaking of Kent, we have Ken Hovind with us this Tuesday. Okay, guys, so you can see in the event section, what I'm going to do is start setting them ahead of time, just so it's not like a day's notice. You guys can prepare yourself, especially because we always open it up like we do with Professor McQueen for questions from the audience, creationists, and skeptics as well. So we're going to have Kent here Tuesday. There'll be a Q&A from the audience. Throw me your questions. We'll get to as many as we can. Then the very next day, we're going to have Dr. Jonathan Sarfati on, author of Refuting Compromise, where he just absolutely demolishes the arguments from Scripture when it comes to old Earth creation, theistic evolution. So we are going to have Dr. Sarfati debunk some of the most common arguments from Hugh Ross, and Inspiring Philosophy recently put out a video called The Top 10 Arguments That Young Earth Creationists Can't Debunk. So we're going to have some fun debunking that video. It's not going to be difficult, so we're going to have some fun. Be there with your questions, okay, guys? And then Dr. Rob Statler is going to be back with us on the 8th, as well as a debate with David Neff and Bill Morgan. So right now, we're going to leave it with just the people that we have in here right now. We're going to go over a couple things. We're going to start off with a video from Gutsick Gibbon going over junk DNA related claims. We're going to debunk it, and then we're going to open it up for everybody. Any skeptics or atheists want to join as well, of course, I'll send the link out, and we'll make sure it's cordial, respectful, equally timed. We'll make it a good night. So before we get it going, and I share screen and play this video, that's only like a minute, so we'll get through it quick. Everybody that's in here so far, me, Brother Neff, Brother Will, and Brother George, guys, thanks for being here. We're going to have some fun.
Sounds like fun, man. You know it's going to be fun.
It's always fun, isn't it, Neff?
Oh, yeah, it's always fun.
Demolishing from evolution.
You know what? Yeah, go ahead,
Happy
George.
New Year, Nev. Happy New Year, Will.
Happy New Year,
gentlemen.
Standing, do you mind if I do a quick prayer before we start everything?
Sure, brother. Sure.
All right. Lord God, we ask you that you give us wisdom and knowledge to destroy those who hate you and guide us towards the truth. And may you open their eyes if they're willing to see the truth. Amen.
Awesome. Amen, brother. Amen. Happy New Year to everybody, as George said. And George, great job yesterday with Professor David McQueen. That was a great stream on the flood. So, and your jokes were as good as ever, brother.
Thank you. I won't joke today. All I'll do. I don't know if you guys remember the old cartoon George of the Jungle.
Oh yeah.
The song went like this: George of the Jungle, watch out for the tree, bang.
I gotta say, I do remember that.
Yeah.
So I've got Rational Empiricist here as well. So we'll open it up for him too. If you want to unmute yourself, thanks for being here as well. Actually, what should we call you in terms of the stream? My good man.
Anything's fine.
Okay, so we'll call you anything.
How are you, anything?
How you doing, anything?
Good. You yourself?
Good, man. Good. Thanks for joining. So what we're going to do is we're just going to open it up with a short clip, something for us to comment on. And I'll even post the link in the chat again. I think David Neff is joining us. Snake was right, possibly. I sent him a link. And then anyone else in the chat. So we'll make our comments on this video. And then I guess at the moment, anything.
Yeah, real quick.
We've got you, who's the only skeptic so far, but we'll get some more as time goes on. And as I said, we're going to make sure that equally timed, respectful. Dr. Will, go ahead, brother. I apologize.
Real quick for everyone, I'm gonna be dropping a free book in the chat, Destroying the Myth of Junk DNA. So if everyone want to install it, feel free to do it. It's just destroying the critics.
All right, awesome. I appreciate it. Okay, why don't we mute ourselves for this? I'm going to share screen, and we'll play this video real quick.
Evolutionary theory makes that ID doesn't. So intelligence design. So evolutionary theory predicted that life can be traced back to a single or a handful of common ancestors. This has been shown to be the case via thousands of phylogenetic analyses, all of which show a gradient of shared and novel traits across life with no line in between the clades. Evolutionary theory also predicted that the genome would contain gratuitous redundancy and junk DNA. That's kind of what we call it. Now, while this is contested by some members of ENCODE back in 2012, subsequent work, specifically some knockout tests, as well as testimony from actual ENCODE researchers themselves, have shown us that the maximum functionality for the human genome is likely between 12 to 25%. Primarily, ENCODE's results come from a very generous usage of the word, of what the definition rather of the word functional. So this is a very generous estimate for full functionality, and I'm happy to have that discussion. Evolutionary theory predicted that endogenous retroviruses were the remnants of ancient viruses embedded in the genomes of organisms, which can aid in tracing lineages. These ERVs revert back to behaving like viruses when xenotransplanted, and they corroborate classic phylogenies. Evolutionary theory predicted that humans would be shown to be genetically closest to the great apes, recapitulating what the morphology dictated decades earlier. Even creationist taxonomists were saying this. Linnaeus was famous for saying, I'm going to bring down the wrath of all the theologians because I simply can't figure out a reason to put humans as not apes. Now, not only are chimpanzees and bonobos our closest living relatives, but our shared similarity across the genome is greater than both those shared between rats and mice and those shared between lions and tigers. This technology.
All right. And so, yeah, why don't we get the party started? So a couple claims I definitely want us to address. Since I'm hosting here, I won't be the first one to speak on it. I've definitely got some things to say. And Brother Neff has made some good comments on this already. Erica's saying max 12 to 25% functionality in the genome, which I think is ridiculous and unscientific and nonsense. I don't know if she's willing to put that on paper as a prediction. A future testable prediction. We'd have to ask her that question. But Neff, anybody on the panel, I guess we'll start with the creationist side. What are your thoughts?
Well, evolutionists hate ENCODE. They hate any scientific project produced that produces results, data that contradicts their bizarre evolution myth. And ENCODE is one of the things I hate the most. When I debated Dr. Dan Larhammer of Uppsala University, you could almost hear him cringe when I mentioned ENCODE. And this is the case with all evolutionists because the data produced by the ENCODE project it contradicts the evolutionists' idea about junk DNA because of their findings. And this is how evolutionists hate real science. Major projects. I mean, ENCODE and the Human Genome Projects were multi-billion-dollar projects. Mm. These weren't some little thing run in the back room of, some small university. This was multi-million-dollar genetic projects. And numerous scientists around the United States and some in Europe were involved in this. And it's hard to argue against the data. You can infer what you want from the data. You can look at it and you can with your rose-colored glasses interpret it how you want. Maybe anybody can do that. But the data was pretty hardcore, and that there's no reason to call anything we see in the genome to be junk. So because of what it's the discovery is about, its functionality. And so here we just see Erica railing against science, against the ENCODE project, because of the data it produced and the fact that what it produced was a powerful argument that refutes the idea of the junk DNA. And
Mhm.
so here is a beautiful example of evolutionists despising science.
Amen. Yeah, can I go? Can I go ahead?
Yeah, go ahead, Will.
Yeah. So, watching at a car as a guy that doesn't have knowledge about a car and saying, "Well, because I don't understand what it does," mean it's useless. It's just stupid. Doesn't mean because you don't understand it that it doesn't work. It's just a fallacy. I'm just gonna be ahead and going to quote this guy's Russell. He has a PhD in biochemistry and molecular biology. For years and years, Darwinists have claimed that the most DNA is left over from failed evolutionist experience. This is junk DNA has been offered as evidence for Darwinism and evidence against intelligent design. The only problem with that claim, as Jonathan will show in this fascinating book, is that it is not true. Careful scientists have known for some time that the non-coding region of DNA have all manner of function. So it is not surprising to see prominent Darwinist scientists and their spokesmen continue to push the party line. Not that the evidence against the junk DNA story is indisputable. Its defender will want to beat a hasty retreat. The myth of junk DNA will make it hard for them to recover their tracks.
That's a
And
great
if
one.
we go for another one, sure. Um, so it basically, they have claimed many of yours. This is another proof of evolution just falling apart. All their prediction we should supposed to find junk DNA and all that type of stuff has been refuted. And look, even this is another scientist. I think this guy's an evolutionist. Okay, he says more and more of the genome is functional. Jonathan Walls delivers a powered and carefully researched broadside against the junk DNA hypothesis. Even biologists who firmly reject the notion of intelligent design must surely acknowledge on the evidence present in this timely book that appeal to junk DNA to defend the Darwin frameworks no longer make any sense at all. All right.
Right.
Yeah.
No, those are some good points too. And I find it funny, this whole 12 to 25% maximum functionality. Now, a big reason why they have to deny reality is due to mutation accumulation. And we've talked about this in great detail. So they're really desperate to hold on to the junk DNA paradigm because the more functional the genome is, the faster we are going to degenerate due to these deleterious mutations that are accumulating. But I find this funny, and I'm going to share screen a couple of articles and papers.
Mhm.
We know so very little about what's actually going down on a molecular level, okay, when it comes to developmental stages, embryological development. I mean, there are a ton of developmental windows. Okay, so when you knock these genes out, because Erica frequently will point to mouse genetic knockout tests, and you knock some genes out and there's not really any effect at hand, even though that's false. I'm gonna prove that wrong in a second. But here's the thing: a lot of these non-coding RNAs, including pseudogenes, they're only expressed under specific types of environmental conditions, and these conditions in the lab are very static. So if they knock out a gene that's not even expressed or being used in that moment, then of course it's not going to have an effect. It'd be like taking out the spare tire of your car before you actually need it, before you got a flat tire. Of course you can take it out, the car's still going to be working in that moment. Once you get a flat tire, you're going to wish you had that spare tire, of course. But I find it hilarious how, given all the functions that we know, okay, we now know that non-protein coding, the RNAs, okay, regulate virtually all aspects of the gene expression pathway. We found function in the ERVs, as she points to, as well as intron pseudogenes. We'll talk more about that later. We can go on forever. But all of that combined with how little we know about the developmental stages, the windows, okay? How many genes during those stages are turned on and then turned off, and utilized during the developmental stages and turned off when you're born, and maybe even switched on later on in life through various environmental conditions. Point is, there's so much going on in the DNA during those developmental windows that a lot of the genome is functional during those stages. So to put all of that within 12 to 25% of the genome it's ridiculous. It's pseudoscientific. And if someone has something to say on that, and I was going to screen
Yes.
share.
Yeah.
Go ahead.
Can I start off by quoting Bernie? He's one of the
Ewan Bernie.
the ENCODE scientists. He said this. I get this strong feeling that previously I was ignorant of my own ignorance, and now I understand my ignorance. It's slightly depressing as you realize how ignorant you are. I reckon that's very apt of what's going on. And just to, I was reading a few months ago about the non-coding region, and one article said they identified 4 million. Another one said they identified 8 million on-off switches in that non-coding region. Now,
That's right.
who knows what those on and off switches are doing?
Regulating, likely playing a very powerful role in fetal development during the as Standing for Truth alluded. During the development of a human being, for example, the genes by the thousands are turned on and off in an incredibly complex, orchestrated array. Where some genes are turned on while others are off, and they come and go. It's like a light show going on.
Yeah, that's right.
It's like Christmas tree lights, but across the whole neighborhood, right? Going on and off at different times. And this is what's causing cells to specialize and meschema tissues to grow and develop and move. It's truly the most mind-bendingly complex process known to man is the development of a human being in the fetal stages. And this orchestration of genes being turned on and off is likely playing a role in that process, which is unimaginably complex.
All right.
Exactly. Oh, yeah, go ahead.
I just wanted to say real quick, couldn't we say that if there's a bit of junk DNA in our body, couldn't we just say that junk DNA come from the conception when you're in your mother's wombs? Maybe you use this information for the conception, but after you don't need it anymore?
That's exactly right. So a lot of genes, a lot of gene sequences, and just gene regulatory networks being utilized in these developmental stages and windows. They are essentially kind of like Neff was saying. It's Christmas lights. You got some that are shut off, some that are turned on, and those ones that are turned on, maybe they're turned off at some point, and then the other ones are turned on, like a light show. So once that organism's born, then those gene sequences that were functional during those stages, now they're turned off or resituated or redesignated for future functions through like epigenetics and environment and stuff. So that's right. And that's why they can knock certain genes out. And since these non-coding RNAs, a lot of them are only expressed under certain conditions, these laboratory experiments are doing these knockout tests in very static conditions. So a lot of them are not expressed. But what's funny is I pointed this out to Erica in our third debate when she used that argument. And I said, actually, what's funny is they've recently done tests. So I'm screen sharing. Can you guys see actually this? Yeah. So this is an article based on a paper, but it's talking about these genetic knockout experiments on the long non-coding RNAs that are actually key players in development and disease and function in the immune response. As well, here you can see the research has shown it's involved in gene regulation, chromosome structure, protein production, and other cellular processes. But of course, all of this within 12 to 25%, which is pseudoscience. So here, there's a study. The new study. Researchers selected only long non-coding RNAs found completely outside the genomic regions associated with protein coding genes. These are called long intergenic non-coding RNAs. And I'm just going to go right down to the good stuff. They knocked these out, okay, in the mice. And it turned out that 18 of these gene knockouts showed lethality and were associated with the development of many important tissues in different organs, including lungs, heart, testes, thymus, stomach, colon, and brain. And one that was knocked out was shown to be a key regulator of the earliest stages of embryo development before any organs are even visible. So the point is, this often repeated argument from the evolutionists that, hey, they've knocked out the majority of the mouse genome and there's been no no effect. It's all junk. It's all redundant. No, the fact is they're knocking a lot of these genes out, and it's proving to be lethal and associated with many other important tissues. So I really, really wanted to emphasize that one. Go ahead, guys.
All right, I just want to say that with regards to like the spare tire analogy, it's not just removing the spare tire that would still allow the car to run. No, you can literally remove any of the car's tires, and if it's any of the ones on the car, you can replace it with the spare tire. So actually, if you just do it one by one, you could theoretically get 5 cars, remove 1 tire from each of them, and they would all run perfectly fine because of the spare tire.
Actually, that's a really good point. Boom. It just shows how redundancy, because she said that the evolutionists predicted a lot of redundancy. Well, the evolutionists predicted a lot of evolutionary leftovers, a lot of non-functional evolutionary leftovers, genomic fossils, ancient viruses like the ERVs. And none of these were predicted to be highly essential and functional. And the redundancy that she says we see, as you're saying, it's important. It's good design. Any good designer looks to redundancy as beneficial and essential. So for the evolutionists to look at all this redundancy and just say this is evidence of a long evolutionary history and process of genetic mistakes, that's not empirical. That's their philosophy. Neff, I shared your screen, brother.
Yeah, it's a great quote I put on there, and your point is very good about these knockout tests. And let me give you an analogy. You got a car going down the highway, and let's see, you say, well, you don't need the taillight, and take the taillight off. Somebody takes it off while the car is going down the road and throws it off the side of the road. The car goes down the highway just fine. Doesn't mean it doesn't need that taillight. It doesn't need it to keep going, but it does need a taillight. And so this is the same kind of thing. We don't know. You may not. There's a lot of genes in the genome that aren't what we call protein codes, protein sequences. A lot of genetic information. And so, if you knock out a gene and the organism doesn't seem to suffer any visible effects, doesn't mean it doesn't need that gene. That gene might even be critical during fetal development, as you pointed out, and fetal development might go completely awry without it. So it's I think it's completely unscientific to say, look, we can knock this gene out in this mouse and no effect at all, and then conclude, well, it was junk. That's so unscientific. I mean, it's ridiculous to think that way. That's just not the way science really works. So here's a great quote I would like to point out to you. This is from John Maddock, quoted by W. Wyatt Gibbs in The Unseen Genome, published in Scientific American. Now, in 2003. Now, that's no friend to creationism, Scientific Americanism, highly secular evolutionist publication. They say, I think that this will come back to be a classic story of orthodoxy derailing objective analysis of the facts. In this case, for a quarter of a century, Maddox says, the failure to recognize the full implications of this, particularly the possibility that the intervening non-coding sequences may be transmitting parallel information in the form of RNA molecules, may well go down as one of the biggest mistakes in the history of molecular biology. So it is a huge mistake for evolutionists to declare, even to cling to in our current time. I mean, it was a nifty idea for evolutionists to believe back then, in the 80s, right, or the 70s. But today, for evolutionists to continue to cling to and espouse this junk DNA paradigm after what's been discovered about the DNA having so many RNAs being produced just left and right in areas that were stretches of DNA that were considered junk, and all the molecular switching going on, the things we've been talking about, to cling to it now and espouse it now demonstrates the non-scientific, the anti-scientific nature of evolutionism, and how evolutionists' minds work. They stick, the paradigm must be true, to heck with the science that argues against it.
And here's the thing, Brother Neff, if you actually look, before, Darwin came, right? There was, I don't know what it's called, the morphology, in birds, they have like 5 finger like us. I mean, that wasn't a problem. They were saying, well, It's exactly what our model should expect: common designer, common design. You know, but since now scientists are into that realm of evolution must be true, I must believe in it. They're not allowed to take outside of the box. Of course, you can use it for common design, common ancestor if your head is so stuck in evolution.
Sure.
But
And
they're
one of the
just
most
brainwashed.
obvious things about this whole junk DNA thing is if let's just imagine for fun that the majority of the DNA molecule was junk, leftover garbled mess, leftover baggage
I go against
created by
evolution.
evolution. Actually, as you just said, it actually argues against evolution if it were, because consider if random genetic mutations are able to develop fantastically complex functional genetic information that does marvelous things to design the incredibly complex and functional biological systems and anatomical features of living things. Why would natural selection and mutation not be able to remove the baggage? It makes no sense. It's an incredible contradiction. Mutations and natural selection can design the most fantastic genetic information, but it can't get rid of all the garbage. It doesn't make
Yeah,
sense.
you can waste energy transposing them.
Do you guys mind if I share a video real quick?
Can I just add?
Oh yeah, go ahead. Yeah, go ahead, George.
Can I just add something to what Neff said and what Standing was saying earlier? Dr. Grau, I think everyone knows, is a supporter of the junk DNA narrative. If he's so confident, let's volunteer him to be a human subject for these knockout gene tests. If he's so confident, then he's got no problem.
Yeah, I'll see how much of the human genome is functional.
Yeah, and I'm just, can I just quote again from a book?
Yeah, go. Actually, before you do, I just wanted to point out Lena Powell's comment. Very good. Lots of good input from the chat. Lena says, a large class of this junk DNA forms factories in the cell, helping to produce proteins. Other types of RNA molecules transport the raw material for protein production to the factory sites. Now, when you debate or talk to somebody like Tony Reed, which Brother Neff did, Tony Reed likes to point out a couple places where evolutionists said, yeah, there'll be, a couple functions here and there in the non-coding regions, but the majority is junk. Yeah, that's the point. They may have said, okay, we'll expect some function, but not the amazing amount of function that has been discovered. I mean, ENCODE discovered 80% activity. And as Neff was pointing out, it's interesting that they'll say that this activity is not really useful activity. It's spurious transcription, for example, but it's such a waste of energy and resources for the cell to transcribe all that energy. And what's so funny is, the evolutionists, as Neff was saying, they purport that a fish evolved into a fisherman and a bacteria-like organism evolved into a biologist, but these evolutionary processes couldn't get rid of all of this excess junk that's wasteful to the cell. So I don't find that to be a convincing argument that the activity is simply just spurious or not really useful. No. The most parsimonious explanation is that it's there for a reason. That's why we as creationists, we can make predictions. We can say, okay, based on genetic entropy, there'd be broken genes, there'd be some junk, of course, but not nearly as much junk as the evolutionists say. Erica was saying 12%, 12 to 25%. No, we could say anywhere between, say, 60 and 85%. And we can make some very specific predictions on DNA positions. Hey, if you mutate this DNA element or this DNA position, it'll result in disease because it's important. That's what happens when you mutate highly essential and functional genes. So we can make predictions and they can't. They just have to hold on to the junk DNA paradigm and they have to say that the activity, it's not useful activity, and that's pseudoscience. Go ahead.
It's like they just gotta evolution just have to alter their belief that has been debunked, like the fossil record, embryology, all that type of stuff. I don't know if you guys know the channel Crash Course on YouTube. It's a 13 million subscriber around,
Yeah, I've
and
seen it.
they make video the facts of evolution. I mean, when I watch that, this guy says, "Well, we have similarity in DNA. We have similarity in the fossil so-called record. We have similarity in the embryo." Okay, so since you go from a perspective of mind that evolution is true, of course you're gonna interpret it as this way because you're in the laws of evolution. But you can just say it's a common designer. I mean, of course when you type a keyboard, right? It's the code is 00001 for A. If you if you type R, it's gonna be 000000001. Does that mean they both evolved from the same? No, they have a common design. I mean, this is just so sad how they just gotta think in evolution is true, so everything that we find is proof of evolution and not proof of common design. It's just disgusting.
It is.
As
And I
Dr.
want to make
Gibbon
a point. I
said,
want to make sure everybody doesn't forget that evolutionists continuously repeat this mantra that creationism doesn't predict anything. It's unable to make any satisfy any predictions, but evolution does. That's not true. We're talking about one right now. It was creationists back in the early 1980s and some in before who actually predicted that the vast majority of the DNA molecule would be discovered to be functional and even necessary information. While all this while, and for another 20-something years, the evolutionists declared it to be junk. So the creationists predicted, based on creation, based on the understanding that organisms were designed in the beginning, and that the design was good, and that the DNA represents information that produces an organism, and the designer was good and smart, then it wouldn't make any sense for any reasonable proportion of the DNA molecule in us today to be considered junk. They predicted that it would be discovered to be functional, important, even critical information. Creationists made that prediction 30-something, 40-something years ago. That was a
Yeah,
creationist prediction, and it came true.
yeah, amen.
all right.
And it's
It's
like,
coming true as we speak. We're watching that prediction come true.
yeah, and it's like,
Left.
what is that Dr. Eugene C. Scott? I mean, have you guys ever seen her? She just bashed on creationists online. She's always installed creationists. It just the only reason why evolution is alive, it's because it's propaganda. If they remove the laws, people would stop believing in him. Wouldn't be taught in school. I mean, children are getting brainwashed. Of course, if you're a children, you go to math class, you trust what they say to you. You go to French class, you trust what they say to you. History class, you trust what they say to you. If you go to science as a 7-year-old kid, of course you're gonna trust what they say to you. Why would it be false if everything that they teach is true? It's just a brainwashing. It's super sad because people that get out of school are haters of God.
All right, I just want to say something about what Erica said. Even if she was right, that it's only 12%, that's actually still way too much for evolution to work. Because if you look at the mathematical calculations for genetic entropy, it works at like a 1 and 2% function, because that's what they thought at the time with Kimura and such. And then if you have things like synergistic epistasis or truncation selection, which haven't even been demonstrated, that still only works when the genome is 3 or 4% functional. But when it's at 12% functional, even though that's way less than it actually is, that's already way too much. There's no mechanism that can deal with genetic entropy at that level
Exactly.
of function.
Actually, if I could comment on that real quick, because that right there is a fatal blow. That was a brilliant point. If you watch my second debate with Erica, I actually pointed that out. We debated junk DNA for like half an hour, and then we were just going in circles. She was denying reality. So I pointed out, listen, for sake of argument, even if 90% of the genome was perfectly neutral junk DNA, Erica, that means there's still about 10 harmful, deleterious mutations arising in every person, every single generation. So that means even if, let's take the most fit individuals in a population. Well, guess what? Even if only 10% of the genome is functional, the most fit individuals are still more mutant than their parents, because that's 10 more deleterious mutations every generation. So even with intense purifying selection, this cannot stop mutation accumulation. So they can even though it's not true, okay, even 10%, like you were saying, brother, they've done the calculations, like with Mendel's accountant, for example, which they've thrown in a number of parameters. They've even they've said, okay, let's see. If the genome is only 10% functional, let's put in this amount of purifying selection. Let's put in this amount of beneficial mutations. Let's see if genetic entropy can be stopped. No, it can only be slowed down, but it can't be stopped. Mutation accumulation and degeneration is inevitable, even with a genome of only 10% functionality. Brilliant.
Synergetic epistasis. They'll invent all kinds of things and plug them in as fixers, like you just mentioned one. Synergetic epistasis is another one. They concoct all kinds of ideas to try to solve the issue. I'm just putting on screen a quotation from Scientific American again. Remember, these guys, they fired a creationist back in the mid-1970s. He sued them. They hate creation. And they say, although a very catchy term, this junk DNA repelled mainstream researchers from studying non-coding, that means non-protein producing, genetic material for many years. After all, who would like to dig through genomic garbage? Thankfully, though, there are some clochards who, at the risk of being ridiculed, explore unpopular theories. And it's difficult for them. I'm not going to read the whole thing to you. What he's saying is that the junk DNA paradigm of evolutionism, he's admitting this in a very secular pro-evolution publication here now.
Yeah.
This is how widely it's becoming known to the evolutionists themselves that junk DNA is a failed idea. He's admitting that junk DNA was a bad idea from the beginning, and he's saying he's admitting that this junk DNA paradigm held back genetic science for years because scientists, and they're stuck in their evolutionism, refused to study the majority of the DNA molecule. They concerned their research primarily and almost exclusively with the information that codes the sequences that code for proteins. They're called coding sequences. And they abandoned research into the vast majority of the DNA molecule, holding back genetic science for years. We would know more today about human DNA and what it's doing than we would if that had not been true. So this is just one way in which evolutionism has a negative impact on science.
Yeah, and it's just that it's just really disgusting how they always stick in their mind. Can I play that video real quick? Standing for truth.
Yes, and then I want to point out.
Yeah, go ahead first, and after I'll play.
Yeah, no problem. I wanted to point out to Andrew, who's here. I'm not sure if you had anything to say on this specific topic, junk DNA, and the functionality of the genome. But if you did, feel free to unmute yourself and give us your thoughts. And we won't interrupt you or anything if you wanted to take as much time as you need.
Yeah, to be honest, this isn't really my my area of, I guess, if you could call it, expertise. I haven't really been following the junk DNA stuff lately, but I would say that I would accept I guess pseudogenes at least to some level, but like I said, I don't know exactly how much of the genome that would comprise, so I'm kind of silent here.
Yeah, no problem. I just want whoever is going to be joining, whether it's creationist or evolutionist, I want to make sure everybody feels like they're being able to say what they want to say, right? So I would say the pseudogenes is very interesting because you've got theistic evolutionists like William Lane Craig, and he actually just put out a video the other day where he said that he is okay with ape to man evolution because of the existence of pseudogenes, right? For anybody who doesn't know what a pseudogene is, the claim is that we've got broken genes that we share with the chimpanzee. Therefore, the argument is we must have inherited that broken gene from a common ancestor, right? But here's what's funny is they never predicted that these pseudogenes would turn out to be highly essential and important for healthy life processes in the cell. And it turns out now that a lot of these, so-called pseudogenes, we know so little of the DNA language. So what they think is a mutation oftentimes is overturned. So I think it's better to call these pseudogenes functional DNA elements. But I want to point out that the persistence of pseudogenes in general, to me, is additional evidence on top of the function for their activity. Because as we were discussing earlier, natural selection and selective pressures in the environment should remove these genetic mistakes at some point in deep time evolutionary history. But the fact is, a lot of these pseudogenes, they haven't been mutated to death yet. They haven't been removed by natural selection. There is what's called a lack of selective pressures on the pseudogenes. So that's more evidence that they are functional and active to some extent. Now, here's the thing. Extensive genetic knockout experiments have yet to be performed on mammals and especially humans. It's unethical on humans, right? Who's going to offer themselves up for those experiments? Like George was saying earlier, these guys like Dan Grauer, who say that the majority of the genome is junk. Okay, offer yourself up then for some genetic knockout experiments. Then we'll see just how non-functional these gene sequences are. So it looks like these pseudogenes that William Lane Craig and BioLogos look to as the number one best evidence for common ancestry, even the pseudogenes argument has been overturned and are shown to be functional. Any thoughts, guys?
Yes, absolutely. In fact, Richard Sternberg, the geneticist, has stated, we know now that based on genetic studies, based on experimental studies, that these many so-called pseudogenes don't code for proteins, but have important function in chromosome biology, such as the way chromosome fiber folds. And that's the packaging of the DNA molecule in the cell. So at the very least, they play a role in how the chromosome is wound up, how it's supercoiled and takes its physical structure, which of course is a critical function for cell splitting, cell division. And if your cells don't divide properly and the DNA isn't coiled up and stored and packaged and then split so that each cell gets a copy of the DNA, well, man, you don't have an organism.
Grauer has gone on record as saying if ENCODE is right, then evolution is wrong. Let's say tomorrow ENCODE comes out and they've categorically found out that 50% has function. Will that prove him wrong, or will they just change their story?
Yeah, exactly. They'll
come up with a new mechanism, obviously.
Yeah, they'll say that's exactly what evolution predicted. Same for the fossil record. There's a big absence. Well, they're going erosion. That's exactly what evolution should have. All that dodging mechanism.
I'm going to make an analogy for the audience to help them understand what this whole pseudogene argument is about. Okay. We understand so little of the DNA language. I made this analogy before. It would be like me going over to Russia. Okay, I'm going to let you know, I know nothing about Russian. I speak zero Russian. But they hired me to be a proofreader, okay, for some books in Russian. And I'm supposed to read these books and tell them, this is a mistake, this is a typo, this is not a typo. I don't know anything about the Russian language. So if I point to what I believe is a typo in this write-up in Russian, I could be wrong. That might not be a typo because I don't understand the language. That's what they've been doing over the years. They're pointing to what looks like a genetic mistake or a defunct gene, and they're saying, hey, this is a pseudogene, and we share it with the chimpanzee, which means we must have inherited it. So they're prematurely identifying what they believe are genetic mistakes when it turns out they're not genetic mistakes after all. They're necessary and essential for the cell. So that's what it is. What they previously identified as genetic mistakes, it's been overturned and shown, listen, this isn't a mistake. This is a functional DNA element.
Can I just share this video about junk DNA real quick?
Yeah. Let me
and after we can go over it. Yeah, go ahead, George, sorry.
No, I said go for it, Will.
Oh, okay. Yeah, I'll just show you.
And make sure you're clicking your audio too, because I'm guilty of that all the time.
my new book, Zombie Science, I touch on the issue of junk DNA, so-called junk DNA, about which I wrote another book several years ago, The Myth of Junk DNA. When the function of DNA was first being worked out, biologists realized that only about 2% of our DNA, of human DNA, codes for proteins. And even then, as I point out elsewhere in the book, it doesn't completely code for protein even then. But 98% of our DNA, apparently to them, had no function at all. And so Richard Dawkins and others argued that it was just a leftover from evolution, like a harmless parasite that just hitched a ride on the DNA that actually did something. And so for many years, they argued that 98% of our DNA was junk and that this provided evidence for evolution. Jerry Coyne has argued this way. Francis Collins argued this way in a book called The Language of God. And yet, in the last 15 years, we've discovered that the so-called junk DNA actually serves some very important functions. The year after I published The Myth of Junk DNA in 2011, a project called ENCODE, or Encyclopedia of DNA Elements, came out with a whole bunch of papers documenting functions for the 98% of our DNA that does not code for protein. And the functions have just increased since then. I mean, hardly a month goes by when some other element of so-called junk DNA is not reported to be functional. Now, interestingly enough, defenders of Darwinian evolution still insist that it's junk. They say that the measures of function used by the ENCODE team, namely that it produces RNA, or mainly that's the main function actually, it has a biochemical function, are not really functions when you look at things from an evolutionary perspective. And since nothing in biology makes sense except in the eyes of evolution, in the light of evolution, according to them, it's still junk. So there's a controversy right now between people who study the actual functions of DNA and those who insist that evolutionary theory is true no matter what. The latter, to me, is a form of zombie science. Well, the ENCODE scientists are just good scientists doing their work to find out how something works. I don't know most of them, frankly, personally, but I don't know any of them that would be called creationists or even intelligent design proponents. So they're just doing their work and reporting their evidence. What they're not doing is they're not allowing evolutionary dogma to dictate their results. And that, to me, makes them good scientists.
I can support what he just said, because my daughter has a master's in biological science and she's involved in research. That's exactly what he just said is what she said to me. They clearly go by the empirical evidence rather than what the evolutionary theory would stipulate.
Yeah,
That's why
Yeah,
they're hated
that's
so much by
amazing.
evolutionists.
And they lose their job, otherwise they're called false scientists. They're just gonna get bashed on, like Dr. James Storr. I mean, if you go to his video, Dr. James Storr actually has a video with John Sanford, something like that. And when the video starts, Dr. James Storr says, "I love Jesus Christ, and if you guys are not happy with that, feel free to leave." And you go into the commentary, and they're like, "Well, now he's giving his religion over his mind. He cannot do any more scientific research. He make fake evidence to support his religion." I mean, all that type of hatred from atheists.
You know, if and evolutionists wouldn't believe this if you tell them, but it's simply true that the evolutionists, prominent evolutionists, university professors, who continue to claim, in light of more recent genetic discoveries over the last 20 some odd years, that the largest percentage of the human genome is junk. These people are going to be infamous 20 to 30 years from now. Scientists, even secular scientists, are going to look back at them with embarrassment, and these guys are going to become they're going to be considered the morons of dogmatism in the relatively near future, because they're holding to and continuously espousing something like a guy going down in a sinking ship. He's holding up his flag and screaming, "It's not true. The ship's not sinking." You know, and 20 to 30, for even 40 and more years from now, people are going to look back. Historians of science are going to look back And these guys' names are going to be remembered. They're going to be remembered as the dogmatists who refuse to accept scientific discovery.
And I mean, we can actually see that now from the first beginning of evolution. The guys with embryo lie. I mean, they fake it a bunch of bone. I mean, just think about how evolution started. Darwin, okay, look at it. He was literally riding a horse and he was having Kendall for electricity. And you're saying that this guy's apparently find the most miracle of life. I mean, this guy didn't have a clue of what a cell was. He just says, "Well, we found a couple bone. This is proof of evolution. There's similarity." That was his proof of evolution. He literally says, "Because we find out, the laws of natural selection, or intelligent argument is stupid." No, I mean, if he knew what a cell would, he would say, "My theory is stupid."
Well, this is why they can't make any real specific predictions on DNA function. While on the other hand, your intelligent design advocates, your young earth creationists, we're making very specific predictions on junk DNA and DNA function. And as Dr. Wells pointed out, the evolutionary criticism is the fact that function, according to ENCODE, was defined as specific biochemical activity. So the 80% activity that they discovered, let's say between 60 and 80, okay, give the evolutionists the benefit of the doubt. Yes, that's biochemical. It's not genetic knockout or anything like that. But that's why we as creationists, we can look to the genome, we can look at these results of ENCODE and predict, hey, in the future, when we do comprehensive knockout experiments, okay, on mammals, or we do more comprehensive genetic function tests on humans, then we're going to find more and more functional, especially key functions in embryological development. So we've got these predictions on paper based on our model that God's not going to create genomes of junk. Oh, he's going to create genomes of treasure.
That's why we're perfect in the
To make those
beginning.
predictions. Yeah, go ahead.
Okay, that's why we were perfect in the beginning, says he. And just real quick, I just wanted to add what I actually find to refute theistic evolution out of context. Actually, if you look in the Bible, didn't God make human first and animal on second, or he made
man last?
Man last. Yeah, but I just think from those who believe in theistic evolution, I just think it's like, if you're saying that, Exodus 20 says, "Remember the Sabbath, for the Lord created everything in the 6th day." So you're saying that those 6 days here and the 7th day that you're supposed to rest for a billion of years, right?
Yeah, that theory, that day age theory is so destroyed by Scripture.
I mean,
I would point out that one of the ways in which the evolutionists attempt to keep this junk DNA paradigm alive is, one of the things that's been discovered about so many of these so much of it, is that it transcribes, it's transcribed into RNA, right?
yeah, let's just
What are RNAs? Well, RNAs do all kinds of cool things in the cell. They're gene promoters and lots of stuff. So they're the workhorses of the cell, right? The proteins, the building blocks, and workhorses. But it's the RNAs, the real workhorse of the cell. And so if so much of the genome that was claimed to be junk is being transcribed into RNA, this implies that there's a biological function. Those RNAs have a function to perform. And one of the ways the evolutionists attempt to keep this dead junk DNA paradigm alive is to claim, just because we see and discover that it's being transcribed into RNA doesn't mean it's functional. That is the most nonsensical thing to believe. So essentially what they're arguing is it's still junk, and really what the cell is doing is transcribing a whole lot of non-functional junk leftover RNAs in the cell to monkey up the cell and to become garbage floating around in the cell that has no function. And the cell, over its vast ages of evolution, is not able to correct that and get rid of the garbage dump.
Yeah.
It's just stupid.
Yeah, and real quick, let's just make it clear, for those theistic evolution out there, just think about it yourself. What does God describe as in the Bible? Merciful, loving. So if God used evolution, God would be an idiot. he would be a cruel God. If he had the power to create everything right away, that's exactly what he did. And so if you're saying that God used evolution to sufferance and, bunch of baby dying, and that just make God satanic. It's even worse than Calvinistic God. Anyways, I just want to share another video. I want Neff to give it a thought on it because I think it's really amazing.
Yeah, before you share the video, I want to share something here on ENCODE because Erica was implying that as time goes on, we're in 2021 now, apparently ENCODE is finding less and less function. Well, for sake of time, I'm not going to go through this whole thing. So I decided I'm just going to share this article from evolutionnews.org, okay? Next phase of ENCODE finds more functional information in genome junk. August 4th, 2020. So this is quite up to date. For everybody who wants to read the papers coming from ENCODE, that's cool too. But this gives a nice overview, okay? So if you actually go in and read through here, they're finding more and more, they're testing more and more cell types. But there's still, for example here, the human body is composed of trillions of cells with thousands of types of cells, okay? So there's still so much more of the genome to test, and there's still so many additional environmental conditions to test the genome in, since many of these non-coding RNA genes, as Neff was saying, they're the workhorses, right, of the cell. They are like the behind-the-scenes workers, doing so much to help the protein coding regions of the genome. So there's still so many experiments that need to be done. And yet these evolutionists want to say that max 12 to 25% of the genome is functional. That is premature on so many levels. So if you go here, I wanted to point out, let's see. So what's next for ENCODE? Okay, so it's only getting better and better and better. It points out it is now apparent that elements that govern transcription, chromatin organization, splicing, and other key aspects of genome control and function are densely encoded in the human genome, okay? And it goes on that in part 4 of ENCODE, right? These are continuing research programs. They are going to devote a lot of time to expanding the cell types and tissues analyzing. So the point is, the more that they map the genome and the more functional tests that they do, okay, especially right here, certain stages of development. Isn't that what we've been saying? The more stages of development that are tested, the more, like, for example, I like how they point out silent sequences that only get switched on under unique circumstances. I think it was Brother George earlier that was pointing out we got millions and millions of genetic switches in the genome just ready to be turned on or off through environmental conditions. So it's just, I got to emphasize this. It is not only pseudoscientific, but it is premature for Erica in that debate opening to actually put on paper that the majority of the genome is junk, when there's still so much more to discover and so many more testings to be done. Go ahead, guys.
Oh, could I just add something more to what Erica said in the beginning? I don't know if this was like an organizational issue with her slides or something, but she made the point about ERVs. And then right after that, on that same slide, she said that when Linnaeus was doing the taxonomies, right, he was like, oh, humans are like primates or primates. But what she's missing there is that ERVs were discovered centuries after Linnaeus. So I don't know if she just organized it wrong or something slipped up there. But it just doesn't make sense to put those two ideas next to each other because they're completely separate.
Mm-hmm.
Well, we've got a good caricature of Erica with an egg on her face. Maybe that's apt to show it now. But no, I forgot what I was going to say now. But that's right. I mean, imagine in probably the next 5 to 10 years when the 4D nucleome project results start to come out, just how many more people will end up with egg on their face?
It's not going to do anything but keep getting worse for the evolutionists and the holdouts, the ones who continue to defend the idea that the majority of DNA is junk, are just going to look more and more eggy. That's all there is to it. They're making, I hate to say that, but they're making fools of themselves. even amongst their peers today. And in 20 or 30 years, they're going to be looked at as the buffoons of dogmatism.
All right, I just want
Well-
to say something about knockout tests as well, which is that knockout tests are more conclusive one way than the other. So what I mean by this is that if you knock something out and the thing like dies or loses a function, you're sure that that gene did something, right? Unless you like broke some other gene in the process, you're pretty much sure that the gene did something if you knocked it out and then something bad happens. It's like if you got rid of a letter on your keyboard. Let's say you got rid of A and you try to type apple. Well, it doesn't work. So you know that the A was useful. But now let's say you knock out the Z and you try to type apple. Well, nothing's going to change there, right? So are you going to conclude that the Z is not useful? Well, no, because if you're trying to type another word like zebra, now all of a sudden it is useful. So for a knockout test, you can be basically sure that it has function, but unless you do really extensive knockout tests, you're not going to know that it doesn't have function.
That's a good point. You have to know specifically what to be looking for that has gone wrong in the animal. If it's not visibly apparent in the animal, it doesn't mean that something hasn't gone awry. That's an excellent analogy, in fact. Really good one.
Well, I've written a few programs in the structural engineering side of things with lots of tables of information. I mean, you could go and knock out some of those tables, but the program will still work. It won't make some of the decisions it's supposed to make, but it'll still work. I think Standing Erica mentioned that they've done some knockout tests with some of the mice, and they said, they reproduced without that particular gene and whatever. I don't know much about it. Maybe you can expand on that. Probably Neff will probably know a bit about it as well. So if you guys can like to expand on it.
Yeah,
well, I could just say that genetic information relates to all kinds of things about the biology of an organism. I mean, there might be a gene that regulates, the length of the hair on the animal, or the lifespan of a hair before it's ejected by this organism to grow a new one. I mean, the genetic information there's so much of it, and it's so complex. Because you see an organism and you don't see a visible negative effect because you've knocked a gene out, doesn't mean it's not, as you guys have been pointing out already, doesn't mean it's junk. It just means you don't know what's going on there, as Godzilla Freak pointed out already.
Yeah.
And it could be it could be a gigantic myriad of things, because there is a giant myriad of things that go on biologically in an organism. That gene might do something that we may not even discover the function of that gene for another 30 or 40 years.
Exactly.
And still you've knocked it out and you say, oh, look, it was junk. You don't know that. You don't even have a scientific reason to believe it.
Right, to go back to my point, the moment you have something shown to be functional, there's no way that's like, oh, we thought it was functional when actually it's useless. That just doesn't happen. It's only the other way. So
right.
In terms of functionality, once you've shown it through a knockout test, it's going to stay there, and more can only get added. It will never get subtracted.
Yeah, that's a really good point. That's why it's so premature for them to conclude that most of the genome is junk, because it's just more and more egg on their face, as has been shown and demonstrated throughout history when it comes to DNA function. And I was showing this earlier, Brother George, where there has been studies showing junk DNA is actually required for mice, where they've knocked out a number of genes, long non-coding RNA genes, for example. And let me see here. They carefully screen these RNAs, and when they knocked them out, it was shown to be lethal in a number of developmental, right? Because she was saying that it was there was no effect in development. There's also, and I pointed this out many times too, I did it with RJ Downard, and he didn't have an answer from what I remember, but there's a certain class of retrotransposon, when you knock it out, Okay, the mouse is developing, the embryo is developing. But when you knock out this class of retrotransposon, the mouse stops developing. It dies. That's because even the retrotransposons are essential to development. So, I mean, were mice just dying and no mice were having babies until this retrotransposon was a function was co-opted? So her argument there is premature, and it just shows she's not up to date, for example, on these mouse genetic knockout experiments. And as we've said and pointed out, these experiments are in static environments. They're not very comprehensive. They haven't done enough experiments to conclude, okay, yeah, you knocked out a gene, it did nothing. Well, that's because there's a lot of redundancy in the genome. That gene may not be expressed, or as Godzilla Freak was pointing out, it's like the spare tire. And he made a great analogy showing that that one spare tire is so much more functional in terms of redundancy in ways that I never even imagined, just like the genome. So, yeah, go ahead, guys. What are your thoughts?
Was that a first-hand source? Just for RJ's, you know where I'm going.
RJ Downer, yeah. Second
First-hand source. That's not a first-hand source.
Yeah, so the paper's down here that it's associated with, right here. So I'm sharing screen. Multiple knockout mouse models reveal RNAs are required for life and brain development. So they are doing mouse knockout experiments. So that's the paper. This is Dr. Jeffrey Tompkins, PhD geneticist. This is his assessment of the study.
Is it
It's not true. It's just not true when Erica tries to say that they've done all these knockout experiments on mice and it shows that the majority of the genome is junk. No, it's actually quite the opposite. It's showing that the genome, even in the mice, are essential. Go ahead.
It's just so blatantly wrong. The junk DNA I claim is truly one of the weakest and lamest arguments that evolutionists make.
It's a dodge.
When evolutionists make this ridiculous claim today, I mean, 15, 20 years ago, you're wrong according to the evidence. But today, the evidence is so overwhelming that when people like Erica make this claim, they still hold to this thing. You know that it just demonstrates weakness and anti-science nature of the evolutionists. The funny thing is, it seems bizarre to me that they can't tell what a goofball they're making themselves out to be in light of what's been discovered about alleged junk DNA. Can you not see how goofy you look making this argument today?
Exactly. Science has debunked evolution. It's like it's the same dodge that they take for the fossil record. Why is there no fossil record? Well, punctually, whatever they call it, that you jump from a monkey to a human in like a second. I mean, this is just so stupid. I'm just gonna prove to you guys evolution here. Evolution are gonna be like, see, monkey are acting like humans, so this is proof of evolution. Yeah, I just want to share to you this video, Neff, and you tell me what you think about it.
Did you want to put it on? Did you want to put it on maybe 1.5 times speed?
Oh yeah, I'll put it on 1.5. Yeah.
Oh, and then before you do that, actually, I just noticed, Danny, thanks for joining the chat today. We appreciate your thoughts as always. So feel free to jump in and give your thoughts on this specific topic, and then we'll probably move on.
Is my mic doing that weird thing?
Yeah, you don't sound good.
Oh, my mic sounds fine. Remember last time we discussed?
You don't.
Yeah, there's a bit of I can definitely hear that background buzz.
Still?
Yeah, like you're in a microwave or something.
Are you using? Yeah, it sounds like you're.
Because I was on another platform and I didn't have the issue. There's something weird going on with StreamYard.
Go on cam setting and go on audio and look here.
Yeah, do echo
Can you
remover.
cancel his audio?
Are you on your micro?
Is
Go
this any
ahead.
better? Is this any better? 1, 2, 3. Is this any
Yeah,
better?
it's good now.
Yep.
Oh
Yeah,
my
that's
god, that was
Yeah,
what a,
whatever you did, fixed it.
I
What'd you
literally
do?
just started checking
Oh.
random boxes.
You're good to go. It was meant to be. Go ahead, George. I apologize.
So that's all right. So, Will, that monkey on the skateboard, are you trying to say that they could actually surf from Africa to South America across
Oh
the
yeah.
ocean?
Oh yeah. Even dinosaur could.
I
Right,
think the
No.
land bridge is more plausible, don't you, George?
yes.
Actually, I have maybe an helicopter evolve and then they take an helicopter to there. Who knows? Maybe they'll come out with that. Yeah, I just want to show you guys this video. I just think this is truly amazing. I mean, it's just beyond amazing.
I want to now go to what I think this is what you're about to see. First of all, what you're about to see is going on in you right now, everywhere in you. We're going to let you look briefly at a cell made by the chemistry department at Harvard University, which was getting a little worried they wasn't getting chemistry majors. So they thought maybe they should do something jazzy. So they know the textbooks in chemistry, you know, the chemistry always looks like circles and it's very boring. So they said, let's just actually make it like it is.
So this is basically what's going on in your cells right now. These are different fibers assembling, disassembling your cells.
What
This
is
is a molecular machine that walks around in your cells right now. It's called the kinesin and transports things. So for example, when things want to move around the cells, they don't just float around randomly. They actually
I like
actively
that.
moved around with little machines, little robots, nanobots that power your cells. What you see here is actually an amazing machine coming out of these little pores, which actually assembles other machines. This is like a packaging floor of your cells called a ribosome. It reads your RNA. RNA is, comes from the DNA, is translated into RNA, and then it basically gets read out by these ribosomes, and they make new machines which then do other things. So there's all kinds of machines in your cells, things that rotate, things that walk, things that make other machines, things that read RNA, things that copy DNA, that open,
Let's look at this
shuffle
again
things
while
around.
we talk about it. Can we look at it a second time? First of all, how fast is this in your life? All these things going on.
Oh, some of those things can happen quite fast, some kind of slow. And that's actually an interesting thing with nanoscale. You can create all kinds of timescales depending on how many pieces have to act together. Some things can
Well, that
happen
little guy
in nanoseconds, some in milliseconds, some in microseconds. You know, they're actually they make steps in the kind of millisecond range, I would say.
In what?
Like milliseconds or thousandths of a second. And a little
So
bit.
you can have this.
So it's actually faster than that. It's much faster than that. So they made it kind of looking.
So this is a garbage man. That big wet sack is just cell garbage, and he's going to take it up this tube, or it is going to take up.
Yeah, there are some machines that walk from the inside of the cell to the outside of the cell to kick garbage out, and others that go from the outside of the cell to the inside cell to bring the good stuff in. So they're specialized machines. They only walk in certain directions.
Is this? What about the color? That's pretend, right?
Yeah, those things are so small you really can't.
It would be very dark. I mean, unless you had stage lights or something. This is a copier.
Yeah, that's a copy on it. That little wormy thing coming out is a new protein coming out, and here's a new protein has formed. Two of them linked together, and they make a new nanomachine that goes off to do its thing.
So this is This is what plants have and animals have, and we have. We're built from these things.
Right. This
is
what's going on in your cells right now.
And so you look inside, and I think it would be fair to say that this seems extraordinarily complicated, extraordinarily sophisticated, extraordinarily, to use a careful word, miraculous.
It just happened by accident, guys. Just imagine.
Yeah, well, this is not this is not 1857 anymore, you know. And it's the 21st century. Evolutionism is a 19th century. It's actually older, but as a scientific theory, it's a 19th century myth. Born in a day when people rode horses, lighted streets with oil lamps. Man knew absolutely nothing about biology in the day Charles Darwin wrote his book. If you could bring Charles Darwin to the future and snap him here and teach him some things, show him that video made by Harvard University, explain what it is, what's going on. I've seen that. It's called the Secret Life of the Cell. It's amazing. And show that to him, Charles Darwin would be picking his jaw off the floor. And then snap him back into the past where he lived. He would never have written his book. Never.
I'd like to point out one thing, too, just to leave no stone unturned with Erica's statements there. So she'll look to a paper by Dan Grauer on the maximum functionality of the genome, where Dr. Grauer points out that because of the mutation rate, for example, okay, and because clearly the Earth is not young, and clearly there's been this long, ongoing evolutionary process, right? So he's already assuming universal common ancestry to be true. So therefore, based on mutation accumulation, okay, it's a lot faster than evolutionists ever predicted. He pointed out that most of the genome must be neutral junk in order that the junk areas can absorb these mutations, making them absolutely neutral. But there's no way that you can demonstrate that any mutation is strictly neutral. No, all mutations must have some effect on genotype. So that paper she points to, she doesn't even realize that the evolutionary, the expert in the case of Dr. Grauer, he's first assuming evolution. He's not realizing that mutation accumulation puts shelf lives on genomes, which means genomes can't go back more than just a few thousand years. So his entire argument is pretty much just denying the evidence of mutation accumulation and saying, well, the genome must mostly be junk. I mean, it's all based on a starting assumption of universal common ancestry. So it's not a good argument to be using. And I wanted to point that out.
That's a great point, because we know today that the genome consists of overlapping and nested information. It's compressed information. And so, since many sequences of DNA share base pairs, if you knock out a base pair and it gets replaced with the wrong one, that's a single nucleotide polymorph. If that happens, it's highly likely that mutation, it swapped out a base pair, a nucleotide, and replaced it with the wrong one, affected not just one sequence of genetic information, but likely more than one, possibly several. There's one sequence of amino acids encoded in the DNA that, depending on where you begin reading and where you stop, codes for 574 different proteins.
Oh man!
Yeah, and real quick,
amazing.
It was really great. Me
compound damage. Yes.
Yeah.
Compound damage. Exactly.
Compound damage.
Yeah, guys, thanks for having me in. I'm really sorry, but I'm really dead tired. Haven't slept for around 20 hours, so I'm probably gonna be heading up to bed. But I'll definitely be there tomorrow for the Eternal Security talk. What time are you doing it, Neff? Around?
Tomorrow. Well, I don't know. Standing for Truth and I planned on it. I don't think we've actually set a time, have we? We're going to do some theological talk tomorrow. Standing for Truth. Whenever you think the time would be good for you, I'm free all night, so whatever the best time for you.
Yeah, no problem. We will communicate through email. And okay. Well, yeah, if you, no problem. I'll email you. Thank you for joining us. We did just get Dr. James Carter in here. It is an honor and a pleasure, brother. Thanks for joining us on this important topic. How you doing tonight?
Doing great. It's good to hear from you. Finally get to interact with you live, SFT, and all the rest of the tracing crew here. Just wanted to say Happy New Year's. I can't say too long, but wanted to say hello for a little bit.
Awesome. As I've said before, Dr. Carter, you are always welcome on the channel, and I think I speak for everybody else in here as well. So Happy New Year to you as well. And since you don't have very long, as you were saying, I'll be happy to give you the floor to give us your thoughts. I'm not sure how much of the stream you've actually heard tonight, but we're primarily talking about junk DNA, the claim from the evolutionists that the majority of the genome is junk, and DNA functionality. So, yeah, thanks, James.
Yeah, I've been listening the whole time. I usually do, but I'm usually on my phone in my pocket, so I'm not actively typing or engaging. I'm usually a multitasker, but agreed with everything you said so far. I don't know how, when we don't even know what a lot of the DNA of the genome does, that we can just hand wave and say that this stuff is junk. I mean, there's so many genes that get activated and inactivated that are part of just like your diet. So maybe if you hadn't happened to give a mouse a particular substance, that gene never gets turned on. I've been studying lithium lately because I teach a lot of nutrition classes, and it looks like lithium might actually be one of the trace elements that's essential, and we can add it to the other ones that we need in trace amounts, like copper and molybdenum. Well, actually, that's for B12. But there's a lot of metals that we only need in small amounts because they act as cofactors and enzymes. But with lithium, there's experiments to show that when you take a lithium supplement, and lithium is, you're thinking, wait a minute, that's what our batteries and our cell phones are powered by. That sounds toxic, but you actually get quite a bit of lithium just in your drinking water and in your food, unless where you happen to live is low in lithium in the groundwater, and of course, then the plants don't take it up as much. But when given lithium, it regulates, turns on or turns off about 50 different genes, and you can test this with microarray, these DNA gene chips, and you can see which of the genes are expressing, transcribing into messenger RNA. They may not be made into proteins, but they are sure making a lot of RNA. So they, is that just an accident, or is that RNA having function? And it's looking more and more like it has function. One of those functions is to increase the expression of brain-derived neurotrophic factor, which is kind of like steroids for your brain. It makes your neurons grow better. In fact, there was even a study with people with Alzheimer's where they were given a lithium supplement for, I think it was 15 months that they did the study. And after about 3 months, the test subjects were actually showing improvements in their cognitive function by about 3 months, and it continued to improve until the end of the 15-month study. Who knows if it would have gone longer, their brains would have recovered even more so. But they're also finding that it's important for getting vitamin B12 across the blood-brain barrier. So that's just one example of how one little thing can have a domino effect and drastically change gene expression. If you look at any of these studies, you'll see the scientists give one single type of drug or molecule, and 50 or 100 different genes get upregulated or downregulated. And some of the newer DNA sequencers are actually able to detect some of these chemical modifications to the DNA, like methylation, that's involved in regulation. So there's about 300 or so genes that we've identified so far that have to do with longevity, and you can actually see the expression of these genes in a favorable way pattern depending on lifestyle, on the epigenetic lifestyle. Do they eat a lot of fresh fruits and veggies, for instance, and you'll see more of those protective genes get activated. So yeah, they may not all be crucial genes. You'll still live long enough to pass on your genes, but there are all sorts of transcripts that are being made that we're only at the beginning of scratching the surface of finding out what they all do. And I was surprised recently to find out that the human genome and the chimp genome haven't entirely been sequenced. There's some regions that are very difficult to sequence because you get multiple copies of long stretches of DNA in there. And because of the way that DNA is sequenced, it makes it challenging to put back together these fragments when you have multiple copies of them. So once we may not ever fully know what the genome is, and it's difficult anyway because we all have these mutations. We all have, come from different backgrounds, and so if someone has an A and another person has a T somewhere, and both of the protein products are functional, one might be 10% less effective than the other. Which one was the wild type? Was it the one that was working faster, or is that a mistake and it's working too fast? So it's hard to tell what the exact human genome will be. Even the first one that was published, I think, was a composite of 5 different individuals. But when you hear these numbers, like we're 98 or 99% similar to chimpanzees, and you look at those studies, and they're only looking at a handful of genes that are protein coding. They're not looking at the entire genome. It's a little bit tricky to do whole genome comparisons, but once we finish sequencing our genome and the chimp genome using newer techniques, we might get an idea of just how many differences there are. I mean, even a 1% difference, if we're talking about 3.2 billion base pairs, 30 million base pairs that have to somehow change over, what do they say, like a 4 million, 6 million year last common ancestor split. The age keeps changing, but you could do a back of the napkin calculation to see if we're going through 100 mutations per generation, and the generation time for chimps and humans, I think, is about 25 years, you could figure out just how many changes there has to be to account for those differences. And we already know that the Y chromosomes are quite a bit different.
Well, that's excellent information, Dr. Carter. I particularly liked the point you made about the not knowing if a gene is, if you're talking about enzyme, I guess you're talking about enzymatic activity, where a gene, a chemical process is sped up or slowed down. Maybe I'm wrong about that. And not knowing which one was the original gene, or which one has caused what. Maybe it was somewhere in between and it's been sped up, or maybe it's been slowed down. That was a really good thought. That was a thought-provoking thought.
Well, so many good points. I could probably hijack the conversation now for 3 hours. I'm just kidding. But honestly, that was like, I mean, you just officially put an end to evolution right there.
Oh yeah.
What is your prediction? What could you make a prediction of any kind about what you think will become of this failing junk DNA paradigm in the coming 30 or 40 years of genetic study? Where do you see it going?
I agree with you, Neff. I think it was you that said that this is going to be one of the most embarrassing chapters in the history of molecular biology, about the assumption that so much of our DNA was junk. I mean, it kind of needs to be for the evolutionary theory, because you need to have enough of a sandbox area to play around with. You need duplicated genes, just junk to try to tinker with until it actually produces something useful. Starts, has the right signal to be transcribed and then translated, and then actually have an effect on the organism that's somehow beneficial in a particular environment that gets selected for compared to the rest of the organism. So yeah, there needs to be a tremendous amount of playroom, because you don't want to start tinkering with the genes that are already working.
Right.
And it's tricky too. If you, one of the claims of how you do this is that, well, the gene gets duplicated and then one of those copies gets modified until it eventually takes on a new function. But, doubling a gene is no free lunch, so to say. There's consequences to suddenly doubling the amount of something. Imagine just taking twice as much of whatever medication you're on right now. That could be detrimental. Even if it's slightly deleterious or wasteful, over time that can have consequences. But yeah, there would need to be a certain amount of junk DNA for the theory to work.
And it makes me think real quick, it's like a reservoir the evolutionists need, where you've got all of this neutral junk that can be called upon at some point in the evolutionary process for novel functions, for example. And with the gene duplication, like you said, it makes me think that, based on what we know about deleterious mutation accumulation, Dr. Carter, the genes that are being duplicated are duplicating the deleterious mutations with it. And I would imagine there's now a waiting time problem for that duplicated gene to gain a function, because if it really is just junk, then selective pressures are just going to remove it. So it's not as easy as the evolutionists want us to believe it is, because you'll often hear him say, like Jackson Wheat, when he was debating Dr. Kevin Anderson, he was saying, these novel functions come about through what's called gene duplication, and then neo-functionalization, as in the duplicated gene gets mutated in a way that leads to function. And it's easier said than done, right? That's why a lot of evolutionary theory is just philosophy. So so many good points.
It's not as safe. Just real quick, the doubling of the gene and playing with it is not safe. That sandbox for evolution to tinker around with is full of deadly traps. If you start messing with a gene, and then the protein gets made and loses function for a while, okay, fine, but that's going to act like a monkey wrench. And especially when you start tinkering with it, like, oops, I actually, the molecule, the protein somehow evolved the ability to remove a carboxyl group or add an amine group to something that didn't need it. Now you've created, the chances that you're going to stumble upon something that's detrimental is so much higher than the chances that you're going to randomly create a protein that has a beneficial new function. You're going to create in the process all sorts of detrimental effects if they could even have a function. I mean, it's not very simple understanding three-dimensional protein structure and function, but sometimes the slightest change can have drastic effects. But usually it's in the direction of losing function. Once you scramble an egg, it's hard to unscramble it. If this protein doesn't fold right, the cell is very efficient at getting rid of it. I mean, if that was the case, we would see all sorts of proteins being produced that didn't seem to have a function, but were on their way to evolving to something new. Why don't we? Because the cell is so careful about getting rid of those misfolded proteins and sending them to the recycling bin, because they would wreak havoc in the cell. They could totally mess up pathways. They tie up resources. They use up energy as well as building blocks that could otherwise be used for the cell. And so you don't see at the cellular level all sorts of in progress protein evolution, just like you don't see in the fossil record a whole bunch of millions of trials that to try to bridge the gap between two closely related organisms and see a bunch of intermediates in there. I mean, you should expect a lot more of that with all these dead ends in the evolutionary timeline.
Speaking of that, maybe I'm wrong, but isn't it true, or am I mistaken, that you pointed out the specificity of proteins and how critical that is to their functionality and the negative effects mutations have upon them? Isn't it true that Alzheimer's, one of the causes of Alzheimer's, or maybe a side effect, is that a deformed protein is produced that attacks the brain in some kind of way? Isn't that a mutated protein sequence?
Yeah, I think it's a tau protein, and I haven't studied it in a while, but I'm getting ready to teach pathology again for the second time starting next week, so I'll look into that one again. But yeah, it does have to do with protein that is not functioning properly, just like prions. You don't hear much about them anymore, but they're proteinaceous infectious agents that basically have a domino effect, like where one of those prion proteins gets in your brain and it starts mutating and changing the shape of the other proteins in your brain until they misfold and form holes and pockets in your brain.
Oh my goodness.
That's what you call it, spongiform encephalitis. Your brain turns to sponge.
Wow.
And happens in sheep. They call it scrapie because the sheep, they lose their minds and they just have a tendency to want to scrape up against fences. So they basically rub their wool off. And, you can find it in deer, of course, cow, we call it mad cow disease. In humans, it's called Creutzfeldt-Jakob disease.
Thanks, evolution.
Yeah, right. And that's not the only, there's actually quite a few diseases that have to do with misfolded proteins.
Well, I like the way you put it. I'll say one quick thing, and I know there's a couple people who I think wanted to ask you a question, Dr. Carter. So I like what you said about, once you've scrambled an egg, it's now incredibly difficult to unscramble it. And that's what we're seeing with a lot of these misfolded proteins. And earlier you were pointing out that just one minor change, and I think this is key, that's why I want to reiterate it, one minor change can have a drastic ripple effect in gene expression. And we're learning so much more about, as you were saying, Dr. Carter, epigenetics and how the environment can affect our genetics simply through diet. And I agree with you 110% on that. So there's so much fascinating data and so much more fascinating work that needs to be done, that these evolutionists saying that, the max functionality, 12 to 25%, it's just so premature. So I just want to point out, I love what you're saying here, and I don't want to hog the mic anymore because I know there was a couple of questions. I think Danny or Will.
Yeah. I wanted to ask, this notion of function, right, is actually a very problematic term with respect to science. Normally, it's used in a normative way outside of science. For instance, if I talk about the function of a hammer, I'm talking about its purpose, its utility, what it's for, right? And that, namely, I would argue, is an intentional concept. So then, if it's the case that biologists or scientists are not using the term in that way, as if not to imply a mind, right? When they talk about, let's say, the function of the heart, they must be referring to what it does or what it does normally, right? In which case, if you talk about a function of a gene, you're talking about what it does normally or what it's doing at the moment, right? But then that would mean that everything has a function, right? Including the quote unquote DNA or junk DNA, or the DNA that is not expressing itself, indeed has a function of not expressing itself, as if as the conditions are that it's not doing anything that's normally. So that would be tied to the way that the biologist is using it function. Now, what I'm hearing you say a lot is you seem to use the word function as if to imply a mind, right? Which seems to be a different diverging. You're diverging from the way that scientists normally utilize the word function.
So would you like a qualifying word in front of it, like has potential function, or has function, or can be part of a larger function? Or
it's not so much a criticism as just, what do you mean by function?
Well, what do you think would be a better word than function to describe? Because you could say the DNA has function. The function is to make a protein that is going to have another function, and that function may not even arise until it partners up with 20 other proteins. So that its function is to play a small part in a larger systematic function. So when I say it, I just mean it in a loose general term of
what it does normally.
At some point, under the right conditions, it will have a cause and effect in the cell.
The right conditions, but that's a normative notion too, right? If as opposed to the wrong conditions, right? So there would still be something to differentiate right and wrong conditions. Now, I guess I personally, it's my belief that scientists shouldn't have the privilege of using such a term unless they're just talking about its behavior, but not really. It doesn't make sense to say that a physical thing should be doing something if you're appealing to a physical fact to establish what it should be doing. Because
Danny, what if we change function to prescribed purpose?
That's what I take function to mean outside of the caricature of the physical.
Well, would you apply this same way of thinking to anything that has apparent function or is known to have been designed for function? Or is it just that which is biological that you take issue with the term function? Because that's the observation I make for most the evolutionists.
I'm just
They're
saying
happy acknowledging that this or that, this and that have a function, but when it comes to biology, they seem to have a whole different set of a way of looking at it. It's in any term that implies a mental process which prescribes something for a purpose. Then that's when they go into this. Well, I have a problem with the word function, or is it really information? That's not really an algorithm.
I kind of see
we just call it that.
This isn't to. Oh, I was just going to make one point, Danny. And this isn't to be rude. It sounds kind of semantical to me, because if we were to look at, let's look at a vehicle, and let's look at just one of the number of parts that are essential to that vehicle. Take a brake. What's a brake used for? Well, its purpose is for slowing or stopping a moving vehicle. So that is its function. That is its purpose.
Right, but
how would you describe that? How would you describe?
I think that's perfectly. Here's my point in summary. If a biologist points to a hammer and says its purpose or its function is to put nails through things or whatever, right? That I think that they're equivocating, right? In the cases where they're pointing out the function of, let's say, a gene, right? If they're not referring to a purpose, right? I think you're going to find it very difficult to convince, let's say, a non-theist, right, to say that there's purpose with respect to genes, but they're going to accept, right, that there's a function with respect to genes, which is an equivocation on my view.
If anyone has anything to say, I'll just quickly say that I'll just point out the fact that when we're looking at genetics, when we're looking at genes, they are essentially sets of instructions that they determine what the organism is like. They determine everything about the organism essentially. So it is a function would then have an outcome on the organism. And when we look at the number of functions, whether it's in gene expression, regulation, embryological development, we see a purpose. There is a functional outcome to what that genetic sequence is doing.
I guess that's what I was asking of Dr. Carter is are you using function in that way as to imply a purpose?
Well, I mean, probably in the back of my mind, since I do believe that these things had an intelligent purpose in mind, and they weren't accidents, they weren't the products of random mutations, natural selection. So, but when I say function, I just mean it in the most general terms that conveys the usual message. I mean, if you want to get down to semantics, come up with a better term than function that we all
it's
can
not.
agree on.
I think it's conceptual, right? Because when I say that there's some X has a function, I'm talking about what it should be doing, not what it is doing. But science is in the business of what is happening, not what should be happening. Right? So that's the crux of the issue, right? If you attribute a function to something, are you saying that it should be that way? Or are you saying that's what it is doing? Now, do you understand that the problems are huge if all you're describing is what it is doing? Otherwise, as for example, if your heart stops pumping, that's what it is doing. But we're going to say that's a malfunction. It shouldn't stop pumping, right? But I just don't see how that's a scientific question if we're asking what the heart should be doing. The only science that to be had there is what it is doing.
Well, go ahead, Dr. Carter.
But then for instance, if you're looking at a protein, that if you can find out what the normal role of that protein is, and the product of that, let's say it's an enzyme, and you see a certain amount of product being made, it's converting substrate into product, and if that product is not being made at all, or if it's being made less, and you compare that in different organisms, and you say, okay, 99 times out of 100, this is the product. So that is the normal function. And anything that does not meet that expectation is dysfunctional.
Yeah, I think that's how most scientists use the term, the way that you just described. I'm just saying that there's a technical issue, a conceptual issue with that. If they're saying, I don't think this is what you said, right? But if what's being said, right, is something like, based on what it normally does, this is what it should do, right? That's a fallacy, right? But if you're just saying what I mean by function is what it's normally what it normally does, that's a different claim than saying that this is what it normally does, therefore that's what should happen. I don't know if that makes any sense.
So you're saying like this is what it ought to do when you don't have all of the information to make such a predictive claim like that.
Well, I guess these are two. Look at these two propositions, right? Function just means what it normally does versus what it normally does is what it ought do. I think these are two separate claims, right? The second claim I think is a fallacy, right? To say that, because I mean, just think about our world, right? If we were to say that people normally have sex outside of marriage, right? That doesn't mean that's what you should do. I mean, that's what normally happens, right? To equate an ought with what normally happens is fallacious. I think it's called the naturalistic fallacy, actually. But if all biologists are saying is something like this, all I mean by function, I'm not talking about what should happen. I'm just talking about what normally happens, right? And then so we can say that the function of the gene, all that means is that what it normally does, right?
Which may or may not be known.
Yeah, I just want to, real quick, because there's people that wanted to join. I just want to ask a quick question, and after I'll leave the room to let some place, if possible.
Go ahead, Will. Yeah, I know you're tired. I'm getting tired myself.
Yeah,
I've already got my pajama bottoms on. I'm styled like a like a mullet. You know, it's okay looking up here, down there. It's like white trash. You know, I'm ready to hop in the bed.
Yeah, Mary, Happy New Year. I just wanted to ask you a quick question. So you have the nucleus in the cell, right? And you have the mitochondria. You know, you have some DNA there and some DNA in the cell. So I was just wondering, how can, it's such a little, it's so small, like it's not even understandable. How can you possibly see like 3 billion letters inside of the nucleus? How can you see that by your eyes and have all the coding, like, the 4-letter A and C and T and G?
That's very technical. You can see DNA when it's bundled up in the chromosomes, when it's condensed and wrapped around the histones in a light microscope, but you can't see the individual bases. And there's different techniques for actually determining the sequence of those base pairs, but it's not something that you can see. I mean, you might be able to see the general outline in an atomic force microscope, but yeah, if you want to see what DNA looks like, there's a fun experiment you can do. Usually use strawberries because they're octoploid. They have 8 copies of their chromosomes. And just take some frozen strawberries and take a little bit of salt and dish detergent and squish up those strawberries in a Ziploc bag. You could blend them, but you don't want to do it too much because it'll destroy some of the DNA. And then filter it out with a cheesecloth so that the salts and the detergent, they help precipitate out the proteins, and you get rid of the fiber and stuff, and you'll pretty much be left with a syrupy DNA concentrated solution. Yeah, and then add some cold alcohol, like 70% isopropyl alcohol, rubbing alcohol, or even higher if you can find it, like 92%. Add it cold, and then stick a toothpick in there and twist it around, and you'll pull out. You'll see the DNA precipitate out of solution when you add the alcohol, because the alcohol competes with the water of hydration needed to solubilize the DNA. And so it'll suddenly look like a loose cotton ball inside. And
that's kind of amazing.
Take a matchstick, toothpick, or a glass rod and twist it, and the DNA will stick to that because DNA has a lot of negative charges from all those phosphates in its backbone. And you can see what DNA looks like, but you're looking at, massive amounts of DNA, because think about that, 3.2 billion base pairs, which, if you lined up all the chromosomes, would be about 6 feet long. That's crammed into the nucleus of each of your cells. So, the amount of DNA, if you dried it out and put it in a teaspoon, that would have all the instructional information for every species on Earth. It's very information dense.
All right, thank you a lot, James. Thank you, everyone. God bless you all.
Yeah, all right. Have a good night. Happy New Year's.
That's a waste. That's a waste of good alcohol, Dr. Carter.
Yeah, I know, especially in the COVID days where you need to sanitize.
That's right.
Well, I can say for a few more minutes that there were some other comments or questions.
I guess.
I was actually reading Dr. Stadler's book last night, The Stairway to Life.
Oh, good.
And I was interested to note that out of the 1,000 prokaryotes that they've sequenced, they didn't find one example of a conserved protein. And what that suggests is it's not a tree, but it's an orchid. Now, further to that, I was reading some other literature about the eukaryotes, whether eukaryotes evolved, and I'm going to throw a few acronyms at you. We all know what LUCA is, the last universal common ancestor, but now they propose that the eukaryotes actually evolved from an archaea, and not just one archaea, but multiple archaeas. And they've thrown a few other acronyms called FACA and LECA. FACA meaning the first eukaryotic common ancestor, and LECA, the last eukaryotic common ancestor. In both examples, they've actually described the creationist view of creation, and that is the orchid rather than the tree. And it was just an interesting analogy. And the more I read about what geneticists themselves are finding, they're actually proving the biblical view rather than the Darwinian view.
Yeah, I'd be careful to use the word prove from the before Danny
Oh,
jumped on
demonstrate,
that term.
demonstrate. Sorry, demonstrate.
Yeah, because technically only mathematics can prove something.
Yes.
Yeah, but give evidence for it. Yeah, that's pretty complicated. I mean, you have to get into what's her name, Lynn Margulis. She passed away, about the endosymbiont theory, and whether eukaryotes came along because of the absorption of smaller bacteria by a larger bacteria, so that they could both grow even larger and have enough dual functions to give themselves enough energy. And they kind of have this mutualism or symbiosis where they each benefit each other to suddenly become the first eukaryotic cell. But that's a really big topic.
I guess the point that I was trying to make, it actually goes against the claim that there can be a set of genetic sequences that don't have a function. If what I'm saying goes through, that claim can't be made.
Well, if let's say a region of the DNA got hit with stray radiation that damaged it, and it got misrepaired, so that it no longer can, maybe it was in a reading frame, and so it no longer even made messenger RNA, let alone proteins, then couldn't you say that the damaged DNA no longer has a function other than to act as a bridging molecule for in between genes that are still functional?
That would depend on whether you differentiate does not have a function versus malfunction. Right. I don't think
malfunction and dysfunction.
Well, malfunction or not, just not having any function. It doesn't seem like any physical system, on my understanding, without appealing to a purpose, okay, just doesn't have a function. It has to have a function if it's construed what I call non-normatively. That's to say, if we eliminated all the purpose or intentional aspect of the concept, right? So if that's the case, because everything is behaving, right? All of the genes are behaving. The fact that it's not expressing itself, or it's not there's no transcription or translation or any of that, is itself a kind of behavior, right? Where it's stationary, right? That's what it's doing, okay? And so if you were to start expressing itself, is it malfunctioning or is it changing its function?
Well, if the function is defined as an outcome, then it becomes outcome-less.
So let's take a sequence of DNA that's usually not expressed, and then we have something like what you considered radiation, okay, and it's suddenly being expressed, okay. That's not what it normally does, right? So it's changing its behavior in a way that's just statistically improbable. Now, is that you could call that malfunction, sure. But if someone were to come along and say, well, that's just a change in function, despite its statistical improbability, right? Would you say that they're missing something?
Just to clarify, I was saying the other way around, that the radiation destroyed a gene that had previous function in terms of an outcome, like it was transcribed and translated, and now it was knocked out, essentially.
It seems like you're using outcome different than effect.
Am I? I mean,
well, the point is that
synonymous, aren't they?
It's outcome changed, right? So you have something that's normally expressing itself, and then something happens to it, an irregular anomaly or whatever, radiation, and then the effect is different. It doesn't express anything different.
You know what you're ignoring, Danny, is that when we throw in between the information in the DNA and the activity, well, let's call it activity for a moment, that results from that information somewhere down the line in the cell, related to other proteins and whatnot, is this enormous complexity and specificity. I think that really gives you a problem with this word solid that you're using, because when we find that complexity and specificity are so enormously high,
I'm granting
we automatically we automatically infer that an intelligence has created this with a purpose in mind, because we intuitively understand that to create something that is through a process that is unimaginably complex and specific requires a very high level of intelligence. And then to simply call it, well, I don't know if I'd call it a function. It's just what happens.
I can
I
grant
think that's
theism.
the
I think
big
you're
failure.
I'm being misunderstood.
No, I think that's the big
Let me
failure of this
clarify.
idea, because it ignores, it really is proposing.
Sir, you're misunderstanding me.
Well,
Let me clarify.
Okay, but I think it's proposing that enormous complexity and specificity can arise by undirected processes.
It's not that's not the point I'm making.
Well,
let me clarify,
hold
sir.
on. I think I struck a chord. Let me finish my statement. So, I think that's not something that's plausible, and I just don't think that. So you kind of made me lose my train of thought.
Well, let me clarify, and then it'll be better, right? Just let me clarify.
It proposes that sort of thing can arise from undirected processes, and we don't have any reason.
No, I'm not saying anything like that. Let me grant, Dr. Carter, that God designed the world, that God created the world. I can grant all of your everything that you want with respect to the creation narrative, right? By the way, in case you don't know, I'm not a Christian, but I can grant Christianity, right? So my point is a little bit it's tangent or peripheral to the question, right? The point is that when my heart stops beating, right, there's a sense in which we could say that it ought not happen because God designed my heart to beat. Okay, that's perfectly fine. I have no problem with that. That makes a lot of sense. In that sense, we can say it's to say that it's functional is it's in conformity with God's plan or it's God's design. If it's dysfunctional, it's out of accord with it. No problem with that, right? Now, what I'm saying is that notion, right, of function cannot be understood apart from a designer. Okay? So when we're using function, right, and purely naturalistic terms, what it has to refer to is what the behavior of the atoms or the molecules of the nucleic acids. It's just merely describing their behavior, right? And this poses a big issue for anyone that thinks that that you can construe a purpose by just merely observing the behavior of such molecules without appealing to an intentional thing, right? So what happens to them as they use the term, right, is that function no longer refers to design, purpose, or intention. It refers to what a thing is doing, right? And that thing can change what it's doing. So the question is, I don't see how they're going to provide an argument for why when it changes what it's doing, that it's a malfunction rather than just a change in function. That's because ultimately, for Christians, right? A change in function means there's going to be a change in what God wants, and a malfunction, right, is going to be something that's out of accord with what God wants, right? So this is my point. So Nephilim completely misunderstood me.
I don't think I did. I think you're changing what you're proposing in response to what I said.
Well, so be it. That's the point, Dr. Carter. The point, but if you're arguing with an evolutionist who does not presuppose a designer, right? Maybe for poor reason. Maybe he thinks, I don't know, that you have to see it to believe it. Horrible reason, I would admit, for disbelieving in God. When they use the word function, it can only really refer to the behavior of what he's observing, not anything. It doesn't. The whole term function loses its normal meaning when we were talking about the function of a hammer, the function of a motor, the function of a wheel.
Yeah, but remember, it's the evolutionist. It's the evolutionary community, Danny, that is saying there is no behavior, absolutely no behavior for roughly 80% of the genome. So the behavior that they see, they don't want to assign purpose to it. So they want to just say function.
Yeah, I agree with you. That's very problematic because the fact that it's not expressing itself.
I think that's the bigger picture here.
Right. The fact that it's not expressing itself counts as a behavior, right? So,
Danny, is prescribed behavior function? Wouldn't you agree that if a behavior is prescribed,
not in itself,
that's function?
No, if I just say that a particular gene stopped expressing itself, that's not sufficient to say that it's functioning or malfunctioning. You're going to need a
But
designer.
I said prescribed.
Oh, sorry. Can you repeat your question? I thought you said
Okay,
described.
No, prescribed. When you agree that a prescribed behavior is a function.
Yeah, that
Okay.
when the prescription itself is it has to.
And that gets back to what I was saying. When we see the enormous complexity and specificity involved between the information in the DNA and the
Yeah, I'm not
behavior,
disputing any of that.
it implies that the behavior is prescribed.
For my point, I can grant all of that.
Okay.
Danny?
Yeah.
Now, hello everybody. Can you hear me?
Yes, we hear you.
Okay. So, Danny, the point here is following. So far, or in the past, biologists have referred to junk DNA as regions of DNA that do not code for amino acids, meaning they have these regions have no function because they do not code for amino acids.
That doesn't follow.
But this was the claim. Non-functional DNA means DNA regions that are not devoted to coding for amino acids. Please, Dr. Carter, is it correct what I'm stating here?
Yeah, well, it depends, because now they're saying that it doesn't have to go all the way to making to coding for amino acids and making a protein. That the vast majority of the genome is making regulatory RNA. So the RNA is not messenger RNA; it's RNA that is involved in, silencing other mRNAs to keep that mRNA from being translated into a protein. So it's
but there's a big problem with what Lena said, right? If what function means...
This was in the past, Danny. In the past, they have stated 2% of the DNA is functional because only 2% or less than 2% are devoted to coding of amino acids. Now we know that not only the protein coding regions have function, the rest, or a lot of, not all, but a very large percentage of DNA is devoted to to production of RNA, messenger RNA, tRNA, and other long chain RNAs. There is a large number of different kinds of RNAs that have function and play a very important role in the cell. So it is.
Go ahead.
Sorry. It is very that notion in the past that only 1.5% of DNA is functional is wrong, totally wrong.
If you define the function as just protein coding, that would limit the description of what DNA is capable of, because
Not only
DNA
that,
is multifunctional.
Hearts wouldn't have a function. Hearts don't. I mean, like hearts themselves are not DNA, but they have a function according to biologists, right? So the notion of function actually can't analytically can't refer to anything about DNA, right? Because organs have function, right? It's like defining the word good, right? It's
well,
not.
You just ignored again my point about when we see such complexity in relationships over long distances of complexity and specificity.
I'm on your team, Nephilim.
I understand, but
what are you? I don't know what you're arguing. I'm for you.
Well, let me make a point real quick, and I've got quote after quote after quote from people like Michael Shermer, Francis Collins, Richard Dawkins. Richard Dawkins, he said this. He said this in 2009. It is a remarkable fact that the greater part, 95% in the case of humans, of the genome might as well not even be there for all the difference it makes. Insinuating just remove 95% of your genome and you'll be fine. But they're finding that that's exactly the opposite. So with what you're saying, Danny, right? The behavior that they're looking at, and I want to represent you accurately, but it's the evolutionists like Richard Dawkins, Francis Collins, Michael Shermer. I mean, I could give you 100 quotes. I mean, at one point in time, and a lot of them are still saying it, as you can see with Erica here, you just knock that all out. There's nothing there. It's just purposeless, functionless. That's the point. But what we're seeing is the opposite of that. We're seeing purpose. We're seeing a lot of these gene regions, these gene regulatory networks. They are highly functional and essential. You can mutate them, and the outcome is malfunction, like Dr. Carter's saying. Go ahead.
I understand you have good arguments for why it's not junk DNA, right? I've even read some stuff before I even met you that this whole notion of junk idea is starting to go away, right? But let's just pretend that some falsehood is true in some other world, that we don't need, or let me put it this way, that this 99% of our DNA was not, wouldn't cause, if we were to be removed, we would be able to live our lives just fine, and there wouldn't be any issues that we would see with respect to our bodies. Let's just pretend that's the case. I know it's not, but let's pretend, right? It wouldn't follow from that therefore that DNA has no function. They can't make that claim, right? Because if they're using the word function, they can't be using it to refer to purpose. Otherwise, they become theists. That presupposes a designer, and they don't want to say that there are any designers of DNA, right? And if they mean it in the way that I characterized it earlier, that it's just referring to the behavior, the fact that it's not expressing any proteins or polypeptide chains or engaging in transcription and translation, the fact that it doesn't doing that, it's doing something else, namely remaining stationary, that's a behavior. And if they've timed function to just behaving, standing still is a behavior, then it does have a function. It's a lose-lose for them. So the criticism I'm giving is actually more towards biologists that are using the word function, right, without referring to a designer, right? I think that's irresponsible. I really do, right? And I'm an atheist.
For me, my starting point is the Bible. As you know, we had a lengthy discussion on this the other day, Dan, and I appreciate your points. So I start with the Bible because I start with the evidence. I presuppose the Bible. The Bible makes some specific claims, and predictions have been made by creation scientists like Dr. Nathaniel Jensen that if God really did create Adam and Eve, let's use humans, for example, and front-loaded their genomes with pre-existing DNA differences, DNA elements, that would have purpose, then from there, the predictions and retrodictions that would flow from that starting point would be DNA function, would be purpose in not only these DNA sequences, but even in DNA elements like pseudogenes, ERVs, retrotransposons. So I am happy to say, hey, I am starting with the Bible, and therefore we are looking to these predictions. We are looking to these retrodictions. And it just so turns out that this is what we're finding through.
I think that's totally, for the purposes of my point, that's totally coherent. I have no problem with that. What I have a problem with is those that don't presuppose a designer and utilizing the word function and malfunction when I think that those terms presuppose a designer. Okay, so if we're trying to understand them charitably, then if the function is not tied to a designer or failure or success, I should say, which is intentional terms, right? Then it's just describing what the DNA is doing. And that's a huge problem for when DNA changes what it's doing, because then I don't see how they're going to be.
Well, for the naturalists and the evolutionists, sure, they're just describing the behavior. Like, hey, this hammer is used for nailing things into a piece of wood. Sure,
they can't even
say
that.
They don't want to apply right. So it sounds like you are. It almost sounds like you're strengthening our argument. Is that what you're doing?
I'm saying that, right? Yeah, I mean, I'm saying this whole notion of junk DNA relies on the notion of function. So then I'm arguing that if you present the term function,
what is wrong with you?
In a non-normative way, right? Then there's an incoherent thing about what their argument against you falls apart, right? Because everything has a function, even if it's not doing anything.
And that's not correct. Function is something that's prescribed.
I agree with you. You're constantly misunderstanding me, Nephilim.
Danny, why aren't you a creationist?
I don't think so. Yeah.
Yeah,
I just wanted to stop you guys there real quick because in respect to Dr. Carter, I know he said that he's in his pajamas, he's getting tired. So I wanted to kind of give Dr. Carter, I want to give you the floor in case you felt like you wanted to say anything. I don't want you to feel obligated to have to stay any longer if you are tired and have to go. So it's up to you, James.
I do. My wife's just texting me. She wanted to spend some time together first. But I want to add too that DNA is really polyfunctional because we used to think of it as just the storage location of the information for proteins, and now we know that most of it has to do with regulation. But there's also some structural and chemical property features of DNA, like where the regions of the kinetochore, where you have these dense areas that the microtubules are going to attach to when the chromosomes are condensed so that they can be pulled apart. There's places where the microtubules need to anchor on to the DNA, and those regions, as far as I know, wouldn't have a lot of transcriptional activity, or at least not when they're being pulled apart, so they can serve as a function there. And there may be other structural functions of DNA, like when you have two histones and they're wrapped around with DNA, there's this obviously a strand that's not wrapped around that spans the two histones, and those areas might be more transcriptionally active, and that's another form of regulation. Or they might just need to be a certain length of non-coding DNA in order to bridge the two areas that are regulated on the histones. So in a sense, the DNA is really polyfunctional. I'll let you guys discuss for a few minutes while I look through the comments. I just want to see if anyone's asked any questions that I can quickly address before I go.
I had a quick question for you, Dr. Carter, before you go.
Yeah, I saw that you wanted to ask. Go ahead.
So if I believe in evolution, personally. So I want to, I guess, ask a challenge question, to see kind of the terms creationists sometimes use. And I think I've used this example with you standing and you Nephilim free. But I just want to ask you, Dr. Carter, about it. So to give a specific example of a mutation, there is a gene in Drosophila called SCOOT that controls the expression of bristles across the adult body of the fruit fly. And a mutation in a specific, I don't know which enhancer specifically it is, but this enhancer is pleiotropic. And this mutation that changed a T to a G in the species D. santamea, in comparison to other species of Drosophila, like when you're comparing the DNA differences, basically you find this mutation. This enhancer mutation caused a decrease in the number of bristles in the near the genitalia of the fruit fly, and in male flies caused a increase in the number of bristles along the forelegs, which are used to for mating success, I guess. And so I guess just before I get to my main question, so you would say that mutations tend to destroy information, correct?
They can destroy, but they can alter. There's very, very few examples of where, how do you improve on the handiwork of God is my perspective. Some people would claim being able to have ice cream as an adult is a beneficial mutation. I would disagree with that, but it's if you're starving to death and the only thing to eat is goat's milk or cow's milk, there's obviously an advantage to that. But it's when you're trying to say that all mutations are negative or near neutral, there's obviously benefits if the environment becomes extreme enough. Like the people that have sickle cell anemia, or one of the most common mutations is where you have trouble regenerating enough NADPH, so you don't make enough glutathione, which is one of your body's best antioxidants. And so when you eat pro-oxidant rich foods like fava beans, it can cause so much free radical damage to your red blood cells that the hemoglobin clumps up together, and then in a microscope it looks like these ketchup spots. They're actually called Heinz bodies because of the scientists who figured this out, but it's a very common mutation. And it's not lethal, but these people are more resistant to malaria because the parasite needs NADPH in order for its life cycle. And so these people are naturally resistant to malaria, but they also undergo more free radical damage and oxidative damage because they don't make enough of their body's own antioxidant. So they actually call it disorder favism, because when you eat too many fava beans, it can negatively affect you with pro-oxidants that are inside of the beans. And so you can make up for it by eating extra antioxidants, taking supplements, eating more fruits and veggies for a higher external, your exogenous antioxidants. So in the sense, you could say that's a beneficial mutation if you're in a malaria laden, a plagued part of the world. But you take that environment away, of course, they're not better off than the wild type.
Right. So I guess I agree with that. So for my question would be, for the example of an enhancer mutation that I gave, I'm kind of looking for the opposite in terms of I guess the first part of the question, because it's kind of a multi-part question, but the first part of it would be what specific part of that enhancer mutation I just gave counts as a loss of information, and why?
Do you know what the role of an enhancer element is?
Yes.
Yeah, because I think some people might be confused when you say enhancer. They're thinking this is a mutation that enhanced the organism.
Yeah. I guess I should be more specific and say regulatory element, perhaps.
Yeah, there's not every gene has these, but upstream of the main coding region that where the mRNA is going to be transcribed from, you'll have these various enhancer regions where certain proteins will bind and bend the DNA and make it easier for the two strands to open and for the RNA polymerase to get in there and also recruit. There's several different proteins that can be recruited to increase the turnover rate to make these messenger RNAs. And so we call them enhancers because they enhance the rate of transcription, especially for very active regions where you need to get lots of protein made over and over again. So so your question about the enhancer was, is there an opposite mutation than what has happened in the enhancer region of the Drosophila DNA? I'm not sure what you're asking.
Well, I guess to clarify my question, so this was a single substitution, and from what I understand of the creation model of genetic entropy, mutations tend to cause a loss of information. So my question would be, for this specific substitution, what would the specific loss of information component be?
Well, it's like mutating part of a paragraph, but you still get the gist of the paragraph. It's not as idealized, I guess you could say, as the original code or the original sequence, because it sounds like these bristles prevent as successful copulation. Is that right? So then they produce less offspring. Are they totally incapable of reproducing? I'm not familiar with this mutation.
Right, and the whole point, Andrew, I was going to just point at the fact that when it comes to genetic entropy and the eventual genetic degeneration of larger mammals, especially humans, it's the fact that most mutations are deleterious. And regardless of if you can get a truly beneficial mutation, like right now through the Lenski experiment, there's a paper that came out that suggests truly beneficial mutations are about 1 in a million. Okay, so they've done numerical simulations. We're very generous considering what you're saying. You know, let's give the evolutionists 2, 3, heck, give them 10 truly beneficial mutations that added information. I don't believe that those are out there. You know, but let's just say they were, give it to them. The calculations have been done because the majority of mutations are effectively neutral. So they have very subtle effects on fitness. Natural selection essentially can't see those mutations, okay? So they get passed on from generation to generation. Now, the majority of even your beneficial mutations are reductive and functionally compromising to the organism. But let's just say the example you're providing, let's just say that's truly a novel example of an information gaining mutation. Let's just say that. Well, those have been considered. You know, these numerical simulations, they've thrown in any parameter you can think of. They've even worked it out that the majority of the genome is junk. Okay, and these papers have been published. You can check them out. And still, the outcome is always the fact that genomes degenerate, even with a huge amount of purifying selection, even with truly novel beneficial mutations. The genetic degeneration can't be stopped. Here, this is why the key question is net gain versus net loss. So that's the point, is you're not going to need 1 or 2 or 10. You're going to need thousands and thousands of truly beneficial mutations to counterbalance the damage. So that's the bigger picture that I'm trying to convey, Andrew.
So if I'm getting that correct, I guess like when a net loss have to be a loss greater than a gain, for instance, is that what you're saying in terms of information?
I guess to make it
information can be altered, but you still end up with the same product. You know, like if a codon for glycine changes from GGC to GGT, you still end up making glycine. So from the protein perspective, it doesn't change anything, but technically you've changed the code, the original information, but it didn't have any detrimental effect. It was a silent mutation.
That's a good point. That's a good point.
So,
it would be like this, Andrew. It would be like climbing a mountain, and you know, you're taking a bunch of steps backward, but once in a while you take a step upward. But then you take another 10 steps backward. Then once in a while you take another step upward. You're never going to climb that mountain, or you're never going to get rich by losing money. You know what I mean? And that's how it is in the genetics, where there's really no amount of beneficial mutations that have been observed that can truly counterbalance the damage done through these low impact, near neutral deleterious mutations. Even these essentially silent mutations. There's papers out now about translational pausing, how the third position codon variation act in a functional means to slow and speed processes in the cell. So it's kind of like your tire, and the treading on the tire it's slowly wearing down where it's almost not noticeable. You know, someone could say, you know, however much the tire wore down today is neutral to the car. It had absolutely no damage or effect at all. But over time, the treading eventually will wear down, where it's damaging, and you got to replace the tires. So even in these redundant codons, for example, you know, enough mutations to them affects the outcome of the organism in a negative way. Is my point. Go ahead.
Right. So I would agree with the redundancy, I guess. Like my question would be, you were saying with your analogy of the mountain, the 10 steps going backward and 1 step going forward. My question is,
million.
In terms of the example I gave, what is the steps backward, I guess, like in terms of that?
Right. And that's my point, is this has all been done and calculated, as in, hey, let's just give the evolutionists a few truly beneficial mutations. So let's say, for sake of argument, okay, that example you're providing, let's just say there truly is no loss of some kind. Let's just say it's not reductive. The point is this has all been done through numerical simulations. And even with a generous amount of truly beneficial mutations that we don't even observe. They're just being generous for the sake of it, just to see what the outcome is. And the outcome is still always genetic degeneration. That's the point, is even if this example you're providing truly is novel and it's truly a step upward, well, you still got a million deleterious ones, which means that one step upward, if it truly is that, it ain't going to counterbalance the other million that are downward.
But
you know what I mean?
But at the end of the day, it's still a fruit fly, just like a human with more hair on his back compared to a human with less hair on his back. There's no change. It's just a micro variation of the same kind. So how is that? How are those extra bristles on the leg of the fruit fly going to result in something that'll produce a non-fruit fly?
That's the point. It doesn't change the structural. It doesn't add new structural design to the body
it's just
plan,
a micro variation,
and it doesn't modify an extant feature so that it takes on new biomechanical function, and so it doesn't participate in the idea that organisms morph into fundamentally different types of organisms over time. If it doesn't participate in that process, then it can't be said to be inducing any kind of evolutionary change.
If you look at the rate of these so-called beneficial mutations and how many of those you would need before another system develops that would somehow create a distinct species, that rate is entirely too slow.
Can I ask a question?
Yeah, go ahead. I got to get going pretty soon, though.
First of all, hi to all. Happy New Year. And
Happy New Year, Luca. Always a pleasure to have you here. And then actually, is the question to one of us or Dr. Because I feel so bad, Dr. Carter, because I feel your pain in that once you get into one of these streams, I'm telling you, 6 hours can fly by. And I've got my wife upstairs who's like, honey, we were supposed to watch a movie an hour ago. So if you have to go, brother,
it's your channel. Right?
No,
yeah, if it's a question for me and it's short, I can take it on.
Okay.
So I think the Dr. Carter here knows that some animal and have some kind of relation. Okay, so it's okay with you that there are nested
hierarchies.
Yes. Sorry, I'm Italian. It can be difficult for me speak.
No problem. I got good friends that are from Italy. And
okay. So you do accept that as a fact, right?
There's nested hierarchies?
Yes.
Yeah, but it has more to do with finding common features and putting names to it. I don't think it suggests that there's common ancestry.
Okay.
It's the same argument. Is it common descent or common designer? But yeah, sure, you can see patterns like, oh yeah, here's.
Okay, so a wolf, a coyote, and a dog are related in your model, right?
What do you mean related?
They came from the same original animal. There are kinds in your model, right?
I don't think so. I think they're different kinds, cats and dogs. But
no. Dogs, coyotes, and wolves.
Their common ancestor, you mean? Did they share a common ancestor?
A kind.
Did they like split off from a single animal that was kind of cat and dog like off of the ark? No, I think there was probably a wolf-like ancestor and that was more canine-like, and then some sort of cat ancestor, maybe multiple, like lions.
Dr. Carter, I think he's talking about a coyote, not a cat.
Yes, coyote.
Oh, okay. I thought you said cat and dog. Coyote. Okay.
No.
Yes, coyotes.
Okay.
Maybe foxes. I don't know where they are. If they came from a distinct kind, or if they I mean, you just look at the variation you see in breeds today. I mean, sure, that was not natural; it was inbreeding, but there's certainly a lot of plasticity in morphology.
Yeah. So we can trace mutation in those animals, right?
Yeah, I mean, you have to make some assumptions, but yeah, just based on like genetic differences and using algorithms, yeah.
So we can quantify how many deleterious mutation they were and quantify what is a loss of information, right?
It depends, because sometimes you don't necessarily know if they're deleterious mutations or if they or how deleterious they were. I mean, they're obviously not lethal, but for instance, dogs have trouble. They don't make salivary amylase, I believe, so they don't digest carbohydrates as well. And cats, what is it? They don't make is it taurine or something? Like they'll go blind if they don't. If they become obligate carnivores because of it. So some of these things are detrimental mutations in the sense that they have limited their food sources now, but they're obviously still able to live and reproduce because they can just eat other foods.
Yeah, but we can trace the original ancestor with that, and also give a good terminology to use for the loss of information and so on. It's my point. To accept this model, I need to see those those clades and
hierarchy.
Yes, and to not for you in general, but for someone trace the original kinds of animals, if you can understand that.
I'm not sure I followed what the question was.
If you have a model to convince me I'm an atheist, okay, you need to produce a model with those kinds and to show me how they degraded to this point, if really they degraded.
Oh, yeah, a model is going to be a lot more sophisticated, comprehensive thing, and I don't really deal with hierarchies. I haven't even really done gene comparisons since I took bioinformatics in like 2002, and it's something that I don't know without knowing what the original kinds were, and because there's been so many even morphological changes since what would have been the original created kinds, it's difficult to tell from the skeletal structure alone, obviously, what those changes are, and looking at extant organisms, ones that are alive that we can take their DNA from and compare. There are still some challenges to that, but yeah, I understand that you would want to have a competing model and competing hypothesis to be convincing. I don't think that the hierarchy, other than showing several different trees rather than one master tree of life, more like bushes, that would be satisfying enough to change your mind. I think it's the totality of all of the arguments that we bring on these channels that would have to be taken into account, or talk to someone who does do cladistics and and hierarchies. And
don't worry, I'm a chemist. I have just a degree in chemistry, so I'm not.
Now that we can talk about. My PhD is in biochemistry. I teach, general organic biochem. I've taught like 15 different science classes.
No PhD here.
That's fine. You sound. You don't have to have a PhD to know a lot.
Yeah, I do follow these debates from sometimes.
Yeah, I've seen you or listened on other channels. Yeah.
Thanks for your answer. I give my turn to anybody who wants to talk.
Yeah,
Please.
I just wanted to say really quick to Standing for Truth before I go that I've been talking to Dr. Hayes, Ryan Hayes. We meet each week with Rob Stadler and a couple of other scientists who are working on some videos to challenge abiogenesis. And I mentioned you were talking about how you wanted us to come on and do a roundtable discussion, and he said he'd be up for that. So if there's a particular topic you want to discuss, or if there's something you want us to choose, maybe something from chemistry, since we're both chemists. He's more of a inorganic and organic chemist, and I'm a biochemist.
Yeah.
But
I have a good paper, and I think it's even there. And it's quite good, and it's about abiogenesis, and it's about symmetry breaking in liquids, so liquid chromatography.
Well, what we can do is, and Dr. Carter, yeah, that would be an honor. I would love to do that roundtable discussion with yourself, Dr. Hayes, Dr. Stadler. You guys are all awesome and a blessing. So to be honest with you guys and your busy schedules, whatever's good and most convenient for you, as long as it's maybe a week notice, then whatever time and day is good for you, I'll fit you guys in, because I think that'd be an awesome discussion. I mean, I would love to just sit back, relax, and listen to that roundtable discussion, and maybe on the abiogenesis, origin of life type issues. And then Luca, you can even send me that paper you have, and that could be something to discuss as well.
I already did.
Okay, perfect.
But I can send you anyway. Don't worry.
Should I contact you maybe through Facebook or email, Dr. Carter, and then we can?
Yeah, that sounds good. And if anyone else wants to pose questions and kind of vote on them, we can maybe pick one that would be interesting. We can give you some advance notice. I know Dr. Stadler is going to be on your channel later. I'm looking forward to that. So he's going to be busy with that. So it will probably be just Ryan and I for now. And then, of course, I'm still working on a much larger presentation that I'll have a live Q&A afterward about abiogenesis, because it's fairly technical. I want to use a lot of illustrations and drawings and examples and analogies. So I want to be able to make that in advance and answer a lot of the questions or address some of the major issues, the challenges that there are. And then after that, and probably more like in the summer or whenever I finish writing the review article on ancient biomolecules in the fossil record, I'll do a follow-up video on that as well. So this can be on just a shorter topic, since we're going to already talk about abiogenesis, and we're working on making some short videos with one of the animators that works for the Discovery Institute. And
that's awesome. I love their video, their short clips.
Yeah, we're gonna make a few. The first couple will be on. Actually, the first 6 will have to do with abiogenesis. So we're writing the scripts for the first 2, and we already know what we're going to do for the next 4. So we'll be putting those out this year as well. But if there was like a quicker topic, we can cover that as well, or answer some questions, or discuss some current events. Be happy to do that.
Amen.
We got to pray for Dr. Hayes. I just had a meeting a few days ago, and he and his family got COVID-19. But fortunately, he's already doing better. He had like a fever for 2 days and was just really tired. And he said he's already starting to feel better. But we should
thank God.
Prayer, because there are going to be some long-term complications from that. But so yeah, probably in the next 2 weeks or so, we can hop on your channel and have a fun roundtable discussion. You guys can email me as well at chemistryofcreation@gmail.com if you have any other questions or things you want me to address on the channel.
Perfect. I love
sure
it.
Great hanging out with you guys.
You seem like a
enjoy
nice
all the
guy,
hard work
Mr.
you're doing.
Dr. Carter. I hope we'll speak again sometime. You
Yeah.
seem like a nice guy.
Absolutely, yeah. Thank you. You got to.
I don't know who you are. All these people know who you are, but I don't know.
I'm fairly new to the YouTube community. I've been listening to these channels since the summer, but not interacting as much just because I'm multitasking. But sometimes I can't help myself, and I'll.
Well, I'm kind of a big
only...
deal. I'm kind of a big deal myself. So if you ever want to talk, just let me know. Okay.
You have a channel there, Danny?
Oh no.
Okay.
I need to get one.
Dr. Danny.
No, I'm a philosophy. I'm getting my master's degree in philosophy, so I have a very different approach to these issues than many of you scientists. So.
All right, sounds good.
All right. Well, yeah, no, that sounds awesome. I think I can speak for everybody, Dr. Carter. In our audience, our supporters, they'd be looking forward to that roundtable discussion as much as me. So we can communicate and coordinate over email, and I guess whatever's best for you and Dr. Hayes. Dr. Hayes is in my prayers, for quick recovery and no long-term issues. And within the next couple of weeks, I would say maybe sometime after Dr. Stadler on the 8th, we can set up a day and time whenever is best for you guys. So I appreciate you giving us your time, Dr. Carter, tonight. I know the wife's waiting, and once again, you're kind of a celebrity around here now, so you are always welcome on the channel. So you're a blessing, brother. God bless you.
Oh, thank you so much. Sorry I didn't get to answer some of the questions in the chat. Happy New Year, Doki Doki. Is it Lena or Lynn? How do you say your name?
Lena.
Okay.
Oh, she's still in here. I didn't see her.
Yeah. Very nice to meet you. I see you in the chats a lot. And if you have other questions you want me to address, just send it at chemistryofcreation@gmail.com, and I'll talk to you guys soon or see you in the chat rooms.
Take care, Dr. Carter.
Take care, Dr. Carter. God bless.
Happy New Year.
Good night.
All right. So what's
Sorry, can I add something to the hierarchy that Luca pointed to?
Yes, please do.
I'd just like you to know, Luca, baraminology is a fairly young science. You, on the other hand, have had 150 years to sort it out, and all you've come up with is a diagram with lines in it and a bunch of missing common ancestors. So I think it's unfair for you to be asking us to give you a pinpointed answer when you can't do it yourself.
Well, you need to start that somewhere, right? And also,
well, give us time. Give us time. Don't you ask us to give you time? Give us time.
Okay, but you need something like that to be accepted as a model. So you need to start. And
well, we
also
will.
We have quite a tree. You would agree with me that we have quite a tree, a lot of species, and a lot of work was done on that. So yeah, we are working on that for more than a century, but we did quite some work. They did. I'm a chemist. It's not my field, but yeah.
I'm really looking forward to Dr. Carter's presentation that he's building. When we'll get to see that sounds interesting. Last week he sent me an email saying that he would like to join my channel for a live discussion. He told me about that thing, and I think that's going to be really interesting. I think he's going to have some impact in the community, and evolutionists are going to take notice when he presents this presentation he's working on with another scientist or two. And I think this is going to be kind of a big thing. I think it's going to cause some ears to itch.
He's really nice. He's a good interlocutor. He'll hear you out and let you respond. Very, very good interlocutor. I like him.
I was hoping Jungle Jargon would join us, because I wanted to ask him, seeing that he lived in the jungles of Brazil. I just wanted to know whether George of the Jungle is based on a real character.
What is wrong with you?
Sorry, a joke. I have to go and take my dog for a walk, guys. It's been nice.
Okay, George, take care, buddy.
George, always a pleasure, brother. God bless.
God bless, man.
Take
Good on
that,
you, praise.
take that evolved creature out and get him to do his business.
Yeah, thank you.
I'm just having chips here, so anybody can jump in. But my question would be, I guess, with the kinds, Luca.
Mm-hmm.
And then I know Rational and Pierce has had some questions too from earlier, but with the hierarchies and the kinds, why do we see that levels of genetic diversity, for example, like that new study that came out from Rockefeller, that there's similar levels of genetic diversity in over 90% of species on the planet in the CO1 gene, that really highly conserved mitochondrial DNA protein, which correlates nicely with our model, where all of these different kinds of animals came off of the ark and repopulated the planet. Because the evolutionists, they had to invoke a selective sweep and a population bottleneck. But when it comes to the kinds and the kind boundaries, this is exactly the type of boundary that we would expect. Luca, what are your thoughts on that?
Okay, I do not know enough to answer, but until you don't have a real model, so with all the kinds, of course, not all of them, it's a lot of work, and I can understand that. But to accept that model, I need to see at least some of the kinds discovered. So I need to see at least some of them.
Well, having creationists.
Sorry?
I'm sorry, I interrupted. Go ahead, finish your thought.
I would love to see some of these kinds in its basically the challenge from Aaron Ra, right? To
I can do that right now.
Original kinds, so the original created animals, or at least the ones in the ark.
The big difference between the creationists and the evolutionists on this is really that the evolutionists are because their belief system is on patternicity and similarity, that they assume they believe common ancestry, and they believe all similarities that they find between organisms are the result of common ancestry. That makes it very easy for the evolutionists to taxonomically organize everything. That doesn't mean that their model is correct. And I think it represents the fact that the creationist model is more cautious because for a number of reasons. One, the genetic incongruencies with some of these ideas of common ancestry. For example, the evolutionists will taxonomically organize fish in a lineage leading to amphibian tetrapod reptile, and eventually reptiles. And there's all kinds of genetic incongruencies with that. I'll give you one. The homeobox genes that regulate the development of the front limbs on reptiles is not the same set of homeobox genes that regulates the development of fins and lobe-finned fish. Had evolution been true, mutations selected by natural selection should have accrued in the information that codes for the limbs, the fins, to transform those genes so that they produce legs. But evolution would have had to have started from scratch and redesigned all the genes necessary to produce legs instead of using the ones that develop fins, while at the same time the evolutionist says the fins morphed into legs. But it's not the same homeobox genes that regulates their development. So that's a horrible, horrible genetic incongruency. And here's another one. The front legs of reptiles is not the same set of homeobox genes that develop the wings in birds, although evolutionists claim that birds evolved from reptiles. So evolution should have modified those genes so that they transformed the information to now develop wings instead of legs. So see, evolution should have preserved that. And that's what would have been beneficial. The changes to the limbs expressed by genetic information would have been selected by the environment, causing the organism's fins to transform into legs or legs into wings. But that's the discrepancy we find is in the homeobox genes, that they're not the same. So that's a huge problem for the evolutionists that they just gloss over. You know, they just, oh well, we'll figure it out someday. But and that relates directly to their taxonomy. Creationists are more cautious, I think. But the evolutionists, I think what a lot of evolutionists don't realize is they're not aware of the fact that there are tremendous genetic discrepancies in the evolution theory when it comes to nested hierarchies and common ancestry that they're just not aware of, because the scientists that discover them don't talk about it openly so much because it's a problem for evolution, and there's an enormous number of them.
I can answer to that.
Yeah, go ahead, Luca. Take your time.
So
much time as you need.
You said quite a lot of things. First of all, from fish to snakes, there is quite a way to go. So I do not know every mutation to fish from snakes because there are related, yes, but it's quite a way to go. So I do not know those difference, but you need to know that a fish and a snake are quite distant. So we have a lot, and birds are still reptiles. So yeah, it's not like that a lizard and a bird are the same thing. Yeah, they are reptiles, but it's like to say we are fish. Yeah, kind of. We are chordates. We are from Carniata, if I remember correctly, but we do not swim and we are not fish. So,
well, that's just more of your assumption, I think. But here's a problem. Another problem that you probably didn't even think about. If how long would it take, and how many mutations would it take to transform the genes that develop the fins in fish into that information which develops legs in land-dwelling creatures? It would be, according to evolutionists, this transition took 4.5 to 6, 7 million years. So, but now imagine that process.
That we are observing this mutation right now, right? There are fish that are evolving.
Yeah, well, we don't see that. We don't see them evolving.
We do.
But now imagine not the mutation, the natural selection preserved those genes as they were being modified so that they produce legs. But let's imagine that evolution had to start by creating a whole new set of homeobox genes and then modify them. Now you've just added to the burden of evolution an enormous amount of time and odds that it's not only going to, but instead of doing the quote unquote easy thing, which would be no easy thing at all, modifying the genes that develop legs, fins, and transforming it into the information that develops legs, but starting from scratch with all new homeobox genes, because that's the only conclusion we can make, since the homeobox genes are not the same genes in not the same locus of the DNA that produce the fins and the legs. See, it appears as though that evolution would have had to have started from scratch and developed entirely new homeobox genes and to make the legs of reptiles. But that's an enormous burden. If it took 4.5 to 7 million years to transform genes that make fins into that information which makes legs, and then how long would it take to come up with new homeolox genes? Now, the evolutionists don't believe that's what happened. But then if you don't believe that's what happened, how did you get the genes to be so different, and how did they get moved? How'd they get moved in the DNA from one location to another? Because when we see mutations that cause the relocation of homeobox genes, is the only mechanism known to do that is called a chromosomal translocation. And the medical science, the papers published on the effects of chromosomal translocation, the shuffling around of genetic genes that develop features in human beings, results in grotesque deformities or stillbirth. The organism dies before it can even be born, or it's born with a horrible deformity. And if it receives that information from both parents, the result is disastrous. Now, you can't believe that evolution proceeds on the back of a process that causes so many events that would, such a grotesque event that should lead the organism to extinction. How does that preserved by natural selection? The list of questions goes on and on and on. I'm only trying to point out that there are horrific incongruencies in the phylogenetics of evolution relating to their taxonomical trees, and evolutionists, most of them are either unaware of them or don't discuss them because they don't like pointing out problems with their similarities equal ancestry idea.
But what I can say, it's for sure that takes a lot of time. But we are observing this kind of mutation right now. There are some fish that are adapting to life on the ground, and I cannot recall.
How do we know that?
Because we are observing them.
You mean you see fish that are capable of waddling around on the floor?
In water, they can prosper, but you can raise them on the ground. I take that from a video from Vice Rhino, but I know for sure about mud skipper. Mud skipper can walk. They can move on the ground. So there's that. So
well, you're just assuming that the organism has evolved that ability.
Well, we know of fish that can do that.
Well, the creatures that do that are living fossils. That's the problem. Well, mud skippers are living fossils. That's the ones you named. Mud skippers exist in the fossil record going back 230 million years. Now, they haven't changed. So the evidence is they didn't evolve. They've just never changed.
You know, right, that evolution, it's not something you need for sure. If you have you are successful, you can stay roughly the same. You will change. Every species has changed. Even the living fossils are not the same. They are really similar, but there are different.
If I could say a couple things, and then Luca, take as much time as you want. With the mud skippers, the whole point is the assumption of evolution is that mud skippers are evolving onto land. But here's the thing: mud skippers are the same in the fossil record, so they've been the same. Today, mud skippers are having babies, and they're having baby mud skippers. And those baby mud skippers grow up, and they have babies, and they're mud skippers as well. So there's been no evolutionary change observed, is the point. It would be like me pointing to a hatchback vehicle, let's say a Chevy Cruze, and tell you that hatchback is evolving into an SUV, just because it may have those features that, based on evolutionary assumptions, this mud skipper is then evolving onto land, when in fact it's a mud skipper. It's got the traits of a mud skipper. Only in the mind of the evolutionists, I think, would they say that it's evolving into something truly novel. But and you can comment on that, but before I lose my train of thought on the nested hierarchies, I wanted to ask you about, because yes, generally we see hierarchies as in the fact that we're going to share more in terms of morphology, anatomy, physiology, and genetics when it comes to humans and chimpanzees than we would between humans and a dog, and humans and a fish, and humans and a bacteria. So this natural hierarchy, it's expected from the creationist side and the creationist model. But here's the problem, is these incongruities, as Neff was pointing out, such as every time that we find a lack of uniqueness in this phylogenetic tree, do they invoke convergent evolution, which indicates independent origins, as we would point out. But one big thing, and then I'll let you comment, is what's called incomplete lineage sorting. And what that is when they're looking at certain segments of DNA sequences, you can do this with the coding and the non-coding DNA, okay? So depending on what you look at, depending on what segment you look at or marker you look at, they are producing completely different lineages or paths, okay, quote unquote, of evolutionary descent. So the whole point is you can look at a variety of DNA segments, and what results is a diversity of evolutionary trees, where it looks like there is this mosaic of patterns, of sequence patterns, which once again demonstrates a lack of uniqueness in the phylogenetic tree. So you're looking at convergent evolution, incomplete lineage sorting. You can look to loss of traits evolution, which points to a lack of uniqueness. So that's the point, is yes, some type of hierarchy is expected. We would predict that, of course. Common sense would tell us. But Luca, what do you do with all of these problems with the phylogenetic tree, Luca? And I know I talked a lot there and brought up a few points there. Just take as much time as you need. Curious as to your thought.
Okay, with nested hierarchy, that word I cannot pronounce. It's completely different in Italian, so it's quite hard.
Hello.
So, hello. Nice to see you.
Hi, Luca.
Hi. Okay. Give me an example of convergent evolution, please, before I go on with my response.
So good. So if you want to stick to convergent, what's that? Oh yeah. So you can look at wings. I was going to point to echolocation systems. Echolocation systems, for example, they have to say evolved independently. So it's like a similar trait that they say evolved independently. So the example of that nephew,
like wings. We have, I think, 4 kind of wings.
Birds, bats, insects.
Yeah, and pterodactyls.
Pterosaurs.
Yes, pterosaurs. They are no longer here, but it's another one. So how we can say, and it's not my field, but how can we say that's convergent evolution? If you look to insect wing and bird wing, they are completely different. Bats and birds, you can tell that, yeah, they can fly, but it's completely different. Bats have their entire hand on the wing. Birds have those fused fingers. Not all of them, because some of them have still claws, kiwi and emus. So yeah, it's quite wonderful to have those. Pterosaurs, I think that was a wing with only one finger supporting that wing. So it's different. It's not the same thing. Okay, they can fly, but they use a completely different method to do so. Bats, they use their hand, and birds have a fused structure, so their entire arm is modified.
Do you know how evolutionists believe bats gained wings? Have you ever considered the rationale behind that idea?
Not so different from a flying squirrel, I think.
Well, actually, they believe that a rat-like animal slowly transformed so that its front legs the bones became long and spindly, and it grew flaps of skin. And while at the same time, its rear legs got diminutive, smaller.
Yeah.
So imagine this process of a creature, its front legs getting longer and thinner and gaining flappy skin on it, while its rear legs are getting smaller and less able to, less powerful.
Mm-hmm.
Why wouldn't a small predator the size of a chihuahua just come along and put an end to it?
I do not know where those creatures were living, like the half wing in dinosaurs.
Couldn't fly yet.
Yeah.
Can no longer run properly.
My point is, look at some dinosaurs. They were using wings, not functional ones, but just feathers on their arms to cover their eggs. So
but how would
they
natural
cannot
selection
fly, but they can do something with it. On bats, I do not know. I never studied the topic, but I can infer that it's something similar. What they
Shut
were
your
doing.
mouth.
Yeah. Sorry.
Ignore him, Luca. That was
Okay. So I cannot know everything, of course, but my answer is maybe there was a reason to those mutations, some advantage of sorts. What was, I do not know. There were predators on the area. I cannot tell you. I cannot. What? Oh, okay. I can just give you the example of dinosaurs. They were using feathers to cover their eggs. They cannot fly. It was not functional as a wing, but they can do things.
I understand, but you have to question how natural selection would preserve such changes if the organism is not capable of running effectively anymore, and it's not yet able to fly. So maybe its wings could do something, okay, cover its eggs or something, but bats have live young, not eggs.
What's the secular hypothesis?
So the question remains, why would natural selection preserve something that's making the organism less capable of good mobility on the ground and yet not able to take to the sky? See, this is one of the ways in which evolution theory contradicts natural selection. Evolutionists don't realize it. Most people don't. But natural selection actually argues against evolution theory in countless examples. For example, the same could be said of insects with wings. If the wings are diminutive and not capable of lifting the animal off the ground, what is the point of the creature of natural selection preserving something that flutters but doesn't provide a lift sufficient to raise the animal off the ground?
On that, I know quite a lot about insects. I did study them in high school. So you know that almost every insect has wings. and the ones that do not are evolved in that way. Like ants, I do not know if you know, but ants have wings.
Yes.
Not all of them.
Yes,
Why?
the queens.
Because they have some parts of their population that cannot reproduce and do not have the whole genome. It's very fascinating.
Yes,
So,
but we're talking about the arrival of the wing. The arrival.
Yeah, it was not in insect, was in some ancestor, because all insects have wings.
Well, you've got to put it. The same argument holds to if you believe that various species of insect didn't evolve wings separately. Then you have to still put the argument still holds to the common ancestor of all insects. It developed wings incrementally. Unless you want to just snap your fingers and say, boom, it had fully functional wings, which would be implausible. That would smack of special creation.
Wings can have
why would natural selection preserve something that flutters but doesn't provide lift is sufficient to raise the animal off the ground?
Wings, now they can let those animals fly, but wings can be used for a lot of things, even when they are not functional. Just think about some insect with only a couple of wings. If you know, insects have 4 wings, but not of all of them. Some have just 2, and the other 2 are used to balance the animal or to protect the animal, like the ladybug. If you look at a ladybug, the shell, it's formed by wings. So
that's a very specious argument. That's a highly specified and particular example. That's not like the wings of the vast majority of insects, though.
Yeah, my point is you can use those structure for other things. So they started with wings. No, there were some other structures. What they were, I do not know. It's not that easy to have fossil of insect for obvious reasons, but maybe they had some other function, like I say to you, protection or to attack something. They were able.
That's the thing. You can't even imagine a good benefit to something that appendage on the back that wiggles around, but doesn't, and has some kind of materials. You can't really posit any such thing. It just has to. It's like an ad hoc explanation. Well, it must have been that it had something other fiction, but you can't really give a rational example of something that would like that would benefit the animal.
I'm not studying these things, but I can tell you maybe there were structure to scare some other animal, because if you have something that move on your back, you can scare the opponent. You can seems to be bigger. Just think how some of the example that I gave to you, and so maybe you look bigger and you can scare an opponent and you can survive to an encounter. It's just an hypothesis, because it's not my field of study. You need to talk with someone that is studying the subject. I know.
Well, I don't see that scare of another creature as a plausible explanation at all. Just don't.
With those flapper, you can look bigger. It's a tactic still used in nature. Just think about some birds that rough their feathers to look bigger and more intimidating. It's something that you can see right now in nature. And
I understand that you believe that. I just
hypothesis
don't see it plausible.
on top of my head. So it's just that we are just talking just for fun. You need to talk with someone that knows those stuff, not with me. Okay.
Well, before it even became a wing, it was a tiny little appendage sticking up on its back. What possible benefit would that have for preservation?
I just gave you an hypothesis.
No, before it's a full appendage, it would have to be a nubbin of some type. It came into being incrementally,
Maybe
unless you
it
want
was
to say it
not
was a grotesque
dangerous for the
mutation.
animal to have, so they kept it. And then they become bigger and they used it for something, and so on and so on. Maybe there were some lumps that give protection, additional protection to the animal at first. I do not know, but you need to talk with someone that knows, if even someone knows, because it's not so easy to tell where those animals came from. You will agree that if my let's call mine model or yours is correct, it's very hard to find those creatures. Okay, they have some hard shells, and I bet that we did find them, but they're very small, and it's very hard to find an actual fossil on anything. So talk about this topic with someone specialized in it. And I do not even know where this group originated. I know that they came from some aquatic creature like shellfish. So
well, you're welcome to believe all of that. The problem is we don't know of a genetic mechanism for the development of something like that. And secondly, we don't have any scientific evidence that it ever happened. We just don't have the development of any novel anatomical feature demonstrated by a series of fossils anywhere in the fossil record for any anatomical feature
I can
of living
argue
things.
that you can look
And
at.
so it's a belief you have. I understand it's your philosophy, but we can't say it's science.
Too, because we have shellfish, we can look at them, and they're really, really similar to insects. So
They evolved from both. That's a fact.
Sorry?
I mean, this is just putting your imagination there when looking at a fossil. You just imagine it happened like that.
Guys, I'm going to take off. I'm exhausted. I can't hardly keep my eyes open. SST,
Goodbye, Nana.
thanks for having me. You guys have a blessed evening. Have a great weekend. I'm probably going to do Standing for Truth, and I were talking about tomorrow having a theological discussion, the two of us, and we may open it up for a mic thing too. But we're going to talk about an important theological thing relating to Christianity tomorrow night. So guys, look for that. We're going to do it on my channel, I believe. So you guys have a good evening. And if Standing for Truth is probably kissing his wife and apologizing for not being for holding this thing so long. Okay, see you guys later. Luca, it was good talking to you. I hope you have a pleasant weekend.
You too, Nev. God bless you, brother. Stay safe. Na 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 na.
Okay. Nice, Pat. And I hope that I'm not giving problems to Standing with his wife at least.
No, not at all. Not at all. We've got.
Okay. I will feel guilty if something like that.
Don't even feel guilty. My wife's in bed right now. I'm just having a late night.
Okay.
But
Standing for Truth, you heretic. I'm condemning you. Bye bye.
I had a feeling that's what you look like there, Will. I saw Godzilla Freak join, but then Godzilla Freak, did you want in, brother? Because we're going
Dude,
on. Yeah, go ahead.
I've been called 4 times at 4 hours in the morning. Like I don't even know who's calling my house.
Oh, here we go. Godzilla Freak. It was saying you need to connect your mic or something. I'm not sure if. Yeah, I was upstairs, so I'm guessing Neff called it a night there.
Yeah.
Yeah, I think. What are we going on? 3.5 hours. Well, I think Godzilla Freak wanted to come in and maybe make a couple points. If you and Luca wanted to say a few things, I got to run upstairs and get a drink real quick, and then
please do
we can talk about whatever. Are you there,
Lena, you there? Praise, you there?
Seems no.
So, Luca, do you have a
Yeah.
doctorate in anything?
No, I just have a bachelor degree in chemistry.
Do you want to do something with it?
Yeah, I want to work with my degree. I'm looking for a job in chemistry or related fields.
Have you seen Breaking Bad?
No, because I've seen the first episode, and
There's a
were
lot
too
of
many.
opportunity. There's a lot of opportunity. Just watch it, and you should get some job.
I actually had some people giving me those opportunities, and I
Are you
say
serious?
them, no.
That's so cool.
Yeah,
Look at that's
no,
pretty
it's not
based.
that cool.
Can anyone hear me?
Yeah.
Ah,
Yeah, we can hear you, bro.
I finally see my bubble grow.
Okay.
It's taking me 2 hours.
You're evolving. You're evolving, Godzilla.
But Luca, it's pretty easy to make meth, right?
You mean drugs? Yeah.
Yeah. Okay, that's interesting.
I also heard it's easy to meth it up.
Two? Sorry, can you repeat?
You can meth up the process as well.
Okay, it's not that easy because you need some compounds that are not so easy to obtain. But if you have the right ingredients, it's easy to do so. Yeah, it's dangerous because everything can go wrong. You can actually make things explode. But yeah, if you have the right ingredients, anyone can do it. Of course, you need a chemist to do things right, but for all purpose that they need, you can put almost anyone behind a bench and do it.
Well, cool.
Yeah.
You just need patience and a good recipe.
Patience, it's more for professionals. If you leave some tag to do the job, I don't think.
Are you an atheist?
Yeah, I am.
Oh, why are you an atheist?
It's quite a long story, but I can tell that I had some issues with my religion. I was a Catholic, and I had some questions, and I give that question to a priest. It
Not very good answers.
Yeah, and so I started my process, and was a long one. I went to other religion first. I did something with Kabbalah because I was dragged on with some friends of mine, and it was quite an experience. I tried with Wicca, and with times I start to grow more skeptic about almost everything, and now I'm an atheist.
Did you ever
From
read the Bible?
I have one on my shelf. I can take it right now if you want.
Have you ever tested the Bible, or just spent as much time as one would need in order to understand what it says, and then sort of decide if it relates to
I
reality?
was quite a peculiar one. Catholics do not read the Bible so much. Not where I
Yeah, they
live.
don't read the Bible because according if you actually go back to the church history in the Catholics, around the 1400, they were literally saying that if someone was reading the Bible by his own interpretation, he should be put to death. So Catholics, that's why they don't want you to read the Bible, because you realize
Look,
the church is false.
I can tell you something even better. My grandma, it's dead. She died some time ago, but she knows. She knew some prayers in Latin because at her time the service was entirely in Latin, and we are talking about some decades ago, not even a century. So yeah, I was quite a peculiar one. I was reading the Bible, and I did um, ask a lot of questions about it.
What do you think is your strongest argument against the existence of God?
I don't think you can prove that God don't exist. I'm just not convinced.
So God could exist?
It's possible, yes.
Oh, okay.
I do not believe that's the case, but you cannot disprove God if you are talking about that.
What if I said that that God was a circle with three sides? Do you think you could disprove that, God?
I cannot.
You can't?
It's the problem.
No, you can. You can in an atheist worldview. In an atheist worldview, you're in an open system. You cannot falsify anything or acknowledge anything. You can just be
We are
deceived by
an
aliens.
open system. Sorry.
Atheists are in an open system.
Why?
Everything's
And what
possible
do
in
you
the
mean
in
by
the
that?
world.
I don't know what he's saying, Luca. Look,
Yeah,
the point is that if
I
I told
said
you, if I told you that God was a circle with three sides, that you wouldn't think that there's a contradiction there?
I cannot disprove your.
Oh, okay. Do you know
your
what do you mean by impossible then?
I say that impossible to disprove God because the God of we are talking about, it's impossible to prove. It's
Yeah, right. I
if
understand
it's
that
outside the
part. But I
reality.
don't
How
understand what
can
you
you
mean by
prove it?
impossible. I just don't know what you mean by impossible.
Impossible to disprove.
No, what's just what do you mean by the word impossible? Nothing about proof. Just what do you mean? If X is impossible, what does that mean? If something's impossible, what does that mean?
That it's not possible.
What does that mean?
That can you not find a way to disprove that thing because it's not even in our reality. It's not like I need to prove that I exist, I can talk to you, but maybe I'm just a bot.
Do you think
So
a circle can have 3 sides?
okay. Okay. Now I get it. No.
It's impossible, right?
Yeah.
Why is it impossible? Because there's a contradiction.
Yeah. Okay.
Right. So if something's
Now
impossible,
I get it.
oh,
Sorry.
okay, no, it's fine. Yeah. So if I told you that God was a circle with 3 sides, that God's impossible, right?
Yeah, I get it. You are referring to the Trinity. Yeah.
Oh no, I'm not. No, I didn't mean to. Right. I'm. Let me better
Yeah,
example.
it's a good point because was not one of my problems with religion.
It's not the Trinity. Look, let me rephrase this. If I said God is a married bachelor, is that God possible?
Could you tell me from which claim do you get facts or?
Yeah, I'm not a presuppositionalist, so don't worry.
Well, I'm just asking you a question. Can't you answer that question?
No, I'm talking to Luca. No, I'm not answering your question. Luca, so do you think that someone?
Right.
Do you think it's possible that someone can be a married bachelor?
No.
It's impossible, right?
Yeah.
So if I said God is a married bachelor, right, then that God would be impossible, right?
Yeah. That's
okay.
God.
Okay. So there's a way to disprove certain concepts like married bachelors and circles with 3 sides, right? So now the question is, if I were to say God does only evil and he also does only good, does that make any sense to you?
No.
Yeah, that God doesn't
part
make
of
any
the
sense,
problem.
right? Go ahead.
Yeah, when I say that's impossible to disprove God, I'm referring to a God, not the Christian one. I think that you can be quite certain about the Christian God because it's quite a mess. Let's face it. But if you are talking about a God,
What do you mean by God? If it's not the Christian
something supernatural that created the
A
universe
figment.
and so on, then I can say to you, I do not know what happened before the Big Bang and so on.
So do you think it's possible that all physical processes are guided by a God? That's possible in your view, right?
Yeah, I do not believe it, but in
But do you have a
theory,
reason not to believe it?
my reason is I cannot prove that God exists. So why believe in it if I cannot even?
Seems like you're concluding something
Of course,
prematurely.
Wait,
exists.
Yes, it's a belief.
Wait. Do you know what the argument from ignorance is?
Yeah.
Okay. So it's something like I don't know how, therefore it's true or false. Some conclusions true or false, right? So you don't know how to disprove. You're not saying you don't know how to disprove God. You're saying it's impossible to prove God because he's non-natural, right?
Yeah.
And you think that only natural things can be proved, non-naturals can't be proved, right?
Yeah, basically.
Okay, so why is it that you think non-natural things can't be proved?
Okay, I'm a scientist, so I'm not in your field. So I deal only with physical things. So science cannot prove or disprove a God.
Yeah.
Philosophy, maybe it's not my field. I know it's possible to do things with it, but I
boring.
Sorry, he's being rude. I like listening to you, Luca. Don't worry.
So Luca, it seems like since this idea that Danny's bringing up, the study of argument philosophy is not really part of your field, you can't really take your perspective as a confident declaration that God can't be proven because your field doesn't deal with it. So you yourself shouldn't be confident on that idea based upon your own position.
But mine is a belief. So I do say that it's not impossible to have a God, but you need to show me that a God is.
Well, look,
true.
the question about what if I don't know how to show you? Let's say I believe in God. I have no idea how to show you that God exists.
Yeah.
You wouldn't be, therefore, justified in the belief that God doesn't exist simply because I don't know the answer for whatever justifies the proposition that God does exist, right? So if you want me to put it in scientific terms, maybe?
Mhm.
Okay. So let's say we're questioning whether a dinosaur exists in Argentina.
Okay.
Okay. And you say, I don't think that a dinosaur exists in Argentina because you can't prove that a dinosaur doesn't exist in Argentina. There's something wrong with that, right? Because what if they were to say the same thing, right? That I think there is a dinosaur in Argentina because you can't prove that there isn't a dinosaur in Argentina, right? So this idea is called shifting the burden, right? The idea is that the question is whether or not a dinosaur exists in Argentina, right? To say that I don't believe in X because you can't prove that X exists shifts the burden to the other side, right? So if the person said, "You're right, I don't have any evidence for you because I haven't really investigated. I don't have any evidence for you that a dinosaur does exist in Argentina." You couldn't conclude from that therefore a dinosaur doesn't exist in Argentina. Does that make sense?
Yeah.
Okay. So same thing with God, right? So the proposition that God exists and there's a proposition that God doesn't exist, right? So you believe that God doesn't exist, right?
Yeah.
But you're not going to be justified because I can't give you a reason or a justification for why he does exist.
Well, my whole point is if you can show me that a God exists, I will change my mind.
That's fair, right? But I think what that gets you to is at best agnosticism.
Yes.
Right. I think you're just saying that, look,
Agnostic, it's a form of atheism. So.
Okay, well then let's just get the words out. I understand there's disagreement about what the words mean. So here's what I'm going to say, right? You don't know either way. You don't have a reason to believe God exists, and nor do you have a reason to believe God doesn't exist.
Sure, he has a reason to believe God exists.
No, shh. No. Okay.
Yes.
So I don't know what you're talking about. Look, the point is that you don't have a reason for either, right? And you might say, well, because of intuitive reason. Well, I don't really have a good reason right now because I don't see a good reason to accept it. I just don't believe. So, but I understand that doesn't serve as a justification for the disbelief in God. But nonetheless, I don't believe it. I reject it. Right? I think that's okay. But you can't make a knowledge claim. You can't say. You can only say I don't believe God exists. You can't say I know God doesn't exist.
Yeah, in fact, I say that I do not believe in it, but I cannot show that a God does not exist. So
right, okay.
Yeah, I'm an atheist because I do not believe in a God. And if you ask me, do you know if God exists?
Do you think rocks
or not,
are atheist?
I will say no.
Do you think rocks are atheist?
I do not think so because
they don't believe in God.
Rock are Christian.
Wait,
rock
no,
are Christian.
Oh, God.
But God do not think so.
Well, right, but you define atheist as that which doesn't believe in God, right?
Yeah.
Okay, so rocks don't believe in God, therefore rocks are atheist.
No, they're Christian.
Or I mean, typically the word atheist just means, like in philosophy, it means that there's a rejection, right? But it's just
a denial of the existence
God,
of
you're
God.
so annoying. You are so annoying, right?
Dude, I've been speaking for like 20 minutes. Like,
yeah, you need to be muted or something, right? Look, the point, Luca,
dude,
that was
speak
just
for like 20 minutes,
Luca,
bro. Chill.
excuse me, Luca. That was just a semantic game I was playing on you. It doesn't really matter how you use the terms, ultimately speaking. But I understand what you mean. But maybe yeah, I'm the worst person to ask for a reason to believe in God because I'm not. I'm an atheist. I actually reject it. I think you can disprove it, right? But I was just wondering. It seems like you're a very honest person.
Yeah.
Yeah, if you ever, it feels really bad to give you arguments against the existence of God in a Christian channel. But if you ever want to talk about it, then we should
I think it's a good thing to discuss these things because discussion are always good. So I'm not here to win or to do good. I'm only here to discuss. So it was quite interesting to discuss with you. I'm not good with semantics, but yes, was good.
Well, do you want me to give you? Well, if everyone's okay with it, I can give you an argument against the existence of God that I accept. That I think disproves it.
It's fine with me. With the others, I don't
Shoot,
know.
Danny.
Okay. Okay. Here it is. Right. Okay. They want to say God cannot fail. Right. Okay. So now, what it means to say that someone has a belief or desire is that these are what I call normative states. Now, let me tell you what a normative state is. A normative state is a state that can engage in consistency relations or create the possibility of failure and success. Let me give you a simple example, right? Let's say there's some truth out here that you ought not lie, or one should not lie. That's a normative claim, right? Okay, because if I say that you ought not lie, does that mean that people are not lying? No.
No.
Does it mean that people are lying? No. It doesn't mean either one. So just from the fact that it's true that one not lie, well, the world could be in a way where everyone's lying or everyone's not lying, right? So but what it means to say that's a true statement is that either is possible. Either is possible, right? So if it's true that you ought not lie, then it's possible that you're lying, and it's possible that you're not lying. Okay. Now, if you are lying, that's a failure with respect to the norm, right?
Yeah.
If you are not lying, that's success with respect to the norm. Okay. So you see how there's a inconsistency relationship between I should not lie and then I am lying. That is it's inconsistent with the norm. And I should not lie and I am not lying. That's consistent with the norm, right? So that's what I constitute failure and success. Now, I think that beliefs and desires function the same way. Now, watch this. I just used you should not lie. I'm going to replace it with this. I desire that you not lie. Well, does that mean that you're going to not lie then? No. Does it mean that you are not going to lie? No. But if it's true that I desire that you not lie, right, then that creates the possibility, right, that you may lie or may not lie, right? There's suddenly a consistency relation built upon that desire. So you ought not lie functions the same way as a desire to lie. Now, imagine this. Imagine I told you, well, there's this truth out there that you should not rape. Okay.
Okay.
But there's no possibility of failure. That when it's true that you should not rape, there's always success with respect to it. So look at how it changes the meaning. The meaning you should not rape, given the stipulations I just gave, just means that someone is being raped. Right? Because if I say that failure is not possible, that means that when it's true that you should not rape, there's success, which means that there's rape. So you should not rape when there's no possibility of failure just means the same thing as what? There is rape.
Yes.
If we apply it to desire, right? If I said that I desire to eat food, to drink water, if I desire to drink water, and I said that only means success, then the desire to drink water becomes the state in which I am drinking water. They become indistinguishable,
Yes.
right? So if you think God cannot fail, okay, that means when God desires something, it doesn't mean that if there's no possibility of failure, that means when God desires something, something just happens, right? So let's say God desires, right, that there are 8 planets. What does that mean? There are just 8 planets. No possibility of failure. So the desire can never manifest. It just becomes a success term, which is just a descriptive term. Since the possibility of failure is not ever there. So that means that you cannot have an infallible being. Otherwise, they won't have any desires. But they want to say God wants things. Same is true with belief. Desires and beliefs are usually distinguished, but they share common property. If someone believes, right, that if somebody believes that it's raining outside, does that mean that it's raining outside? No, right? If I believe that it's raining outside, it's either possible that it's raining outside or not possible that it's raining outside. Yes. But God only holds true beliefs. Can't have a false belief. So if you were to say that God believes that it's raining outside, that means the exact same thing as what? It's raining outside. Yes. Right? So God can't have any beliefs because those beliefs become the same thing as what is happening. Right? Whereas when we talk about belief, usually there's the possibility of what? Success or failure, right? If I believe that it's raining outside, I might fail with respect to the truth.
Yes.
Right? So that means that you cannot have a God that is defined as infallible, as well as defined as only holding true beliefs.
I think you got a problem there. The God of
This
the
man
Bible,
just debunked God. What a legend.
No, the God of the Bible is not the universe. He's not he's not pantheistic. He's not he's not creation. So everything that God expresses within himself isn't reflected in creation. It's only when he declares something, an idea, that it affects creation, like in the beginning. That's why it says it's impossible for God to tell a lie, because if he were to say anything different about reality than the way it is, reality would just conform to the new declaration. But
well, I'm having a hard time following you. Look, I'll just ask you, do you think God wants anything?
Yes.
Okay,
anything.
do you think God can fail?
Yes, he says it in Scripture. He says many times.
God fails? Do you
Yes.
think God can hold false beliefs?
God says in Scripture many times, I would have gathered you under my wings like a hen gathers its chicks, but you would not, because he's dealing with free will, something that he will not subvert.
Well, so that means that's interesting. Most Christians say God cannot fail. But what about, do you think God can hold anything false to hold that to be true? Could he have a false belief?
No.
No.
Okay, so then when God believes X, that just means X is true.
Well, Jesus says, I am the truth.
Right, so the point is that the truth itself is not personal.
Well, the truth is for God, yes, because he's not part of reality. He's outside of reality. The universe is a creature. It's not him. So
well,
he can exist.
That.
Well, he can exist completely separate from the universe and be completely isolated.
Look, I'm going to ask you, okay, going back to the desire, do you think God wanted to create the universe?
Yes.
Do you think he could have failed?
No.
Wait. Okay, but if he's not infallible, right? He's fallible, which means that with respect to his desires, he can fail. So if
God is infallible.
The only thing that ever failed was the failure happens within free will of his created beings.
Let's bracket that concern. The point is that you guys want to say that God wanted to create the universe, but that can't be true. All that's true is that a universe began, right? There was never a desire.
Let me jump here. So God can fail if he doesn't implement his will. If he force it, he cannot fail, but he can let people choose to fail. But if he force something, he will never fail.
Now, Luca, I have to go soon, but let me tell you, the argument does not work if they think God can fail.
The argument's garbage, bro.
The argument.
It's quite good.
Yeah. The argument does not work if they think that God can fail. So if they say that God can fail, it doesn't work.
God
right?
can't fail.
Right, but if
the
they
fact
say that it
the fact that he creates free will beings that reject him, that is success on God's part.
Oh, well, there's a
Because-
big. I think there's other problems
Jeremy,
with that, but
just a
Kant
question.
would argue that
Because what he has created is true free will.
success are underneath the existence of God, rather than
But
above.
if God can fail, so it's not
He
omnipotent.
can't.
Yeah. So it's not
God
omnipotent.
cannot fail. If he doesn't implement what he wants,
Yeah.
the
so
human
it's not
will fail. But if he
omnipotent.
push what he wants, the man cannot fail. God will not fail if he push it.
I would say that God has never failed at anything he's ever done.
wanted to do
It's-
or desired to do, right?
Yeah, it's just
Never
that
failed.
when he created free will, he created true free will. So he's created a wild card that he has imposed on himself.
I think
Yeah.
I think there's. I have separate arguments for that. But what do you, Luca? What do you?
Otherwise, there's no other thing you can point to as a failure.
Yeah,
Well, then he
God,
just doesn't
God
have
does-
desires with respect to anything but those agents with free will.
God
Right.
desire all men to be
Okay,
saved, but he
beside-
doesn't force it. That's why they don't get all saved.
Okay, Danny, besides the agents of free will, what failure are you referring to?
There can't be failure, right? Which means
And
there
there
can't be
isn't.
desires.
Well, what
If you
the
can't
desire
fail,
is-
you can't desire.
Well,
No, what if the desire exists at a higher plane than the world? Then you have the desire simultaneously existing with the effect on a different plane.
Wait, is God's desire to create the universe separate from his success?
Yeah, because he implement his fact, he force it.
What would it mean to say that
God doesn't
God
force
wants-
human to be saved.
Look,
the universe is a project that has a desired outcome. And
That
the
can't be true.
The desired outcome is not just the universe existing, it's to have a people for his own. And that will involve eventually destroying the current universe and creating a new one for the people of his own.
Yeah, I think they're. But Luca, what do you think about the argument?
It's garbage.
One.
Well, yeah, I think it's a good one too. Now he's pointing out. Let me give you what Jeremy's trying to say, right? Because this was something that I thought about a lot, right? So they want to say, right, that when there's failure in the world, it's not as a result of God, but it's a result of free agents, right? So God creates something, right, that it has a kind of its own sovereignty, right? Which is to say that God doesn't have this kind of control over it like he had control over the number of planets. Okay? But I think this still falls prey to another issue, right? Think of this, right? If God exists, he would want you to be saved. He would want you to be in relationship with him, right? Now, the thing is that
Yeah, but he doesn't force it.
if it's not possible that you can choose God freely, okay, then God wouldn't desire it, right?
Yeah, that's so stupid.
Because the
That's
point
correct.
is the point is that it doesn't make sense to say that God desires something impossible. Okay,
Taking advantage.
so there's a
Okay.
couple. So the first issue, right, is that in a case where a free agent chooses not to be in relationship with God, right, that means that it was impossible that God could have set up the world in which in which you would freely choose to be in relationship with him. But remember what we talked about, what it meant to say impossible? That means there's got to be a logical contradiction in these two propositions, right? That God desires that you, Luca, choose him freely, and the proposition that God could have arranged the world in which, God could have not arranged the world in a way where you would choose him freely. There has to be a contradiction between those two statements.
Well, he created a perfect world, but he also created the option of the tree of the knowledge of good and evil. So he gave Adam and Eve the whole world, but he held back one thing to remind them that, he had given them everything. And
Yeah, but
that's the one test that God needs to determine if, first and foremost, they're going to believe what he said. Because in order to please God in a relationship, you have to believe him. He's not pleased by anything else but by faith. So
Yeah, but
faith has to be part of that acceptance within that relationship.
Now, Luca, with all due respect to Jeremy, do you think that was a reply to my argument?
No.
I don't think so either.
I also think that God has failed at least 3 times.
I don't think God has failed us all at all, because I think the way he has gone about it in the very limited and finite way that we can even understand him, because explaining God and explaining, you're giving an answer to why God does this or why did God do this. It's kind of like explaining colors to a blind person.
yeah, you're
And God has
judging
done his
God.
best to reveal himself he's from an infinite perspective. He's outside time, matter, and space. We are stuck within time, matter, and space, of course. So the way he's done it is he has given us a choice where we can either choose to love him or choose to reject him, just like he gave with Adam and Eve in the garden, because this is the only way to do it without making robots. And Danny, I know you've heard this over and over again, but it really is, I believe, a sufficient answer. And it is through his plan of redemption where at one day there will be a new heaven, there will be a new earth, there will be no sin, and essentially it'll be perfect. So who are we to put God in a box and say, if I was God, I would have done it this way.
Exactly.
Or I would have done it better. No, the way God has done it is the way that I go about it with my kids. I don't want my kids to mess up. I want them to follow my rules. I'm not going to lock them in their bedroom for their entire lives just to make sure that they don't do anything
Yeah,
wrong.
you don't force your will on them. You don't force it on them.
I was pointing out the other day, I'm 200 pounds. I could easily force her to love me.
Fat boy.
Hey, come here, love me. But no, that would take
There's
away from
I'm a
the reality of
compatibilist,
true
so I
love.
think there's a distinction between cause and force. But I think if you think that cause just means force, that might be one of our disagreements. But I put the argument, Luca, and S50 wasn't here, but there's the argument in the chat, Luca. Do you see it? And the intentional states are normative states. Normative states create the possibility of success or failure. God cannot fail, therefore God can't have intentional states, right? Now, these premises have to be supported, but the argument, at least the first 2 premises, right, follow that intentional states create the possibility of success or failure, right? That's the conclusion of the first 2 premises, right? I accidentally mistyped, but you understand that it would be C, intentional states then create the possibility of success or failure, all right? So you're going to have to argue for the first premise and saying that, and kind of using the comparison between you should lie and I desire to lie versus it is true that X and I believe that X is true are 2 different meanings, right? That that one implies how the world is, whereas the other express how you think the world might be or how it should be or how you want it to be, right? It's normative, right? So if you ever want to, Luke, I'm going to put my email address. So if you ever want to talk more, I know there are a lot of people that want to talk to me now because I could tell I just woke up SFT, and I'm fine with that. But I just because like it is it is something that it's a lot. There's a lot of nuance, right? And there's some
Well, the big
responses.
nuance is free will. It sits between those 2 statements.
Are you a libertarian? A metaphysical libertarian?
I'm not quite sure what that means. What the extent
So
of that means.
there are basically 2 camps of people, of philosophers on free will, right? One camp called incompatibilists. Incompatibilists think that if determinism is true, there is no free will, right? So if you're determined, you have no freedom, right? Then there's the second camp called compatibilist, right? They think that determinism and free will are compatible, that if something causes you to do something, there's still a notion of freedom in that, right? So it seems like you're an incompatibilist. Now,
No, I'm a third option.
You think that determinism and free will are
No, there's a third option.
This is a true dichotomy, though.
No, there's a third option.
It's A or not A.
No.
Well, okay. Let me. Do you think? Look, it's a true dichotomy. Let me give it to you.
No,
Right?
listen to me. Listen to me. There's a third option you're not considering.
Is it compatible or not compatible? Yes, that's a true dichotomy. Which one?
No, there's a third option.
Okay, I don't know.
You see,
Okay.
you are creating a paradigm that God sits outside, and also every person sits outside because we're created in the image of God. The universe could be a long series of cause and effect, but since we are created in the image of God, and that image, like God, sits outside of the cause and effect stream, there's a third option, and that is our free will is not a product of any previous cause.
That's called incompatibilism, Jeremy. You weren't listening.
No, you're assuming.
Can you let people
a deterministic
finish?
framework, which you're assuming a deterministic framework.
No,
that doesn't
incompatibilism
apply.
is against determinism. Incompatibilism is against They think that if determinism is true, there's no free will. That's incompatibilism. So you're an incompatibilist, right? If you just had listened to me.
No, Jeremy, let me just explain this.
Go ahead.
Basically, what he's saying is that with incompatibilism is either determinism or free will. It's like one or the other. Whereas compatibilism is both.
Right.
So either way, it would be incompatibilism under that definition.
Well, I would say that it's using a limited framework that doesn't account for the actual free nature of God.
Why do you think bivalence is some kind of ridiculous limitation?
Valence?
Bivalence, like the three rules of logic: law of identity, law of excluded middle, which is also called bivalence, right? And the law of non-contradiction, right? These are the three rules of logic that are commonly held in classical logic. Okay, now
Well,
there's.
I would say that there is a contradiction in the fact that we contain eternity within us, but we live in a temporal plane.
I'm not on. How does that reply? I don't know.
Because it defies the indices that, as a finite person, you apply with your logic. Your logic is finite. It doesn't account for the infinite nature of God.
Most Christians disagree with that. Like 99% of people that study Christian thought and Christian philosophy are at odds with what you just said, right? Because if what you're saying is true, anything can be true, including God's non-existence and existence at the same time in the same way.
No, but I'm talking within the confines of free will, not in general. This only applies to the free will of man because he's created in the
This
image of
doesn't
God.
look. You're an incompatibilist, right? You think that if determinism is true, free will is not possible, right? That's your view.
Well, it all
Unless
depends
you're a
on what
Calvinist.
it
If you're a
only-
Calvinist,
I'm
you're
not
a compatibilist. Okay,
I'm not
good.
a Calvinist, but the thing is, what I'm saying is, what is the scope of determinism?
Well,
what does it apply to?
I mean, I'm a determinist, right? But I understand that you're not, right? So I think
You
that
have to tell me what is the scope of determinism. What
I
does it
don't know
apply
what
to?
that means.
You know, you don't know what that means. It's because
Well,
you are
I
staying
can
within
give
the
you a
finite
reply.
confines of your logic.
No, I don't understand what you mean by the terms. Like I just think that cause and effect apply to something called concrete objects. Okay?
Mm-hmm.
Concrete objects engage in causal relations, right? There's abstract objects, right? They don't engage in causal relations. The number 9 doesn't cause anything, right? It's causally inert. But your mind, God, this table, right? These things can engage in cause and effect relations. Okay?
Mm-hmm.
So when you ask me what is the scope of cause and effect, I would just say there's a category called that which potentially engages in cause and effect relationships or connections. Those are called concrete objects in philosophy.
Okay, so what about the cause and effect in the spiritual realm?
What about it?
It's not concrete. It's not physical.
I agree. Okay. I agree with you, but I don't think that means therefore there's no cause-effect relationship. After all, I'm choosing to talk to you for a reason, right? My reason is what explains why I'm opening my mouth to talk to you. That's cause-effect.
Sure, but it's a precognitive decision. It's not based on the material of your body. It's based on your spirit.
I'm not disputing that. I agree, but I think my reason is non-material, right? I think my desire to talk with you is not a physical thing, right? I know I'm not a physicalist, right? So, but there's still cause-effect relation.
Mm-hmm. But the Bible does say, "What knows a man save the spirit of man that is in him." So the intent and the knowledge of what to do comes from the spirit, not from the body.
Well, that's still deterministic, right? Because what you're saying is that my desires, or your desires in the case of a Christian, are explained by the spirit, right? Which is a cause-effect relationship. You're still a determinist under that framework.
I would say that you have two parallel scopes, or two parallel determinisms that don't necessarily there's an interaction.
Let me try to.
They're not intrinsically bound together.
Let me try to say what I think you might be saying. The way that determinism works in physical objects, let's say a ball rolling down the hill, that kind of determinism is very unlike the kind of determinism that occurs when you do things for reasons, right? So I will agree with you, right, that the determinism can be described differently. The determinism with respect to physical objects, they are explained by natural laws, right? But whatever happens to your soul, spirit, or mind, right, is not governed by natural laws and thus non-material or immaterial, right? But there's still determinism.
Yeah, but you were originally tying this into God's creation.
Well, no, okay, now suddenly you're no longer an incompatibilist. If you accept that there's determinism with respect to your soul, mind, body, and your intentions and your decisions, your actions, you're a compatibilist.
Well, it's determinism in that it's self-determinism.
I don't know what that means.
It means that I've been given free will. That's what it means.
Okay, so is free will and determinism compatible or incompatible? And it's okay to say I don't know, because I've given you a buttload of information.
Mm-hmm.
If you don't know, then that's fine. We'll drop the subject.
I can't necessarily give you the object or the answer right now. I'd have to think about it a bit.
That's fair. Let's just drop the conversation.
I need the scope of the components of this conversation accurately defined in my mind before I give a
shut your mouth.
Can I recommend a Christian? Can I recommend a Christian source for? And they won't even persuade you one way or another. They're just going to describe the view. Actually, there's a very good book written. It's called Four Views on Divine Providence. I think it's written by an open theist, a Calvinist, a Molinist, and I think an Arminian, right? And they all talk about free will and determinism and God's foreknowledge. And it gives you all basically the four views in Christianity with respect to your freedom and God's foreknowledge and determinism, okay? Calvinists are compatibilist, right? Molinists and Arminians are going to be two forms of incompatibilism, right? Open theists are also incompatibilists usually.
What do you mean by open theists?
Well, they don't. Open theists think that that God doesn't know the future because it's not possible.
Boring.
Boring.
The open theists think that God doesn't know the future because it's not possible to know the future with respect to human intentions.
Boring. Can we change the conversation? This is super boring.
I would just say to finalize this, there's more that could be said. If you were to look up the channel Beyond the Fundamentals on YouTube, it talks about this subject in terms of Calvinism. Calvinism and Scripture. Kevin Thompson, yeah.
Yep,
and
I love Kevin.
He talks about the idea.
Kevin Thompson.
Didn't his channel got deleted?
Luca, what were you saying?
It did, yeah.
Yeah, that's pretty sad.
Oh.
it's a very interesting conversation. But Godzilla, you want to ask me something?
Chad, what are you doing on here? I thought you needed sleep, brother. Like, how much sleep are you getting?
Dude, this conversation has been garbage, bro. Like, I mean, it's just like over and
Okay,
over,
let me
like saying
jump.
the same
Well,
stuff.
let me jump in real quick
What's going
because I
on?
feel.
What's the convo about, actually?
Well,
Dude,
real
like
quick,
this guy's
because I
just
feel
saying
bad
that.
with Godzilla Freak. He was saying a little while ago that he had a question for Luca. So, I mean, maybe you wanted to ask that question now, Godzilla Freak,
Oh
or
yeah, thank you.
Yeah, sure. So with regards to what we were talking about earlier with the development of, say, wings, for example, you would argue that, hey, they might serve some other function and then slowly develop into wings. Well, I would argue that instead, let's say it served a purpose for protection, what would happen is that it would optimize itself for protection through natural selection, and it would fine tune to just be like the best protection mechanism that it can, and stray further away from being a wing rather than getting closer. So let's say at first you have sort of a wing-like piece of armor. Well, if the main purpose of that is protection, then natural selection is going to make it more armor-like, not more wing-like.
Just think about it. If what you are saying is true, we will not have ladybugs and so on, because wings are so good with fly. Okay, and so why we have armor like the ladybug, or some structure to balance the insect like in mosquitoes, because mosquitoes have only two wings. The other two are structure that are there to balance the creature. So it does not work in that way. You can have a mutation that modify does that structure, and that structure can change purpose.
Okay,
And
no,
we
but
can observe it in nature. Just
Hey guys, I'm gonna head out. It was a great
yeah.
conversation. Luca, I'm gonna put my email on the private chat because we're both atheists in the Lion's Den. So if we ever want to talk, without little Baptist Chad saying that this is a garbage conversation, I will. You can
Yeah,
email
you're
me. Okay.
trash, bro. You didn't.
Okay,
You
Luca,
didn't
I just
provide
want to
any
say
argument
that.
against God, dude. That was really bad.
Thanks for
Yeah,
the
so
name.
Luca, I just want to say an explanation like
Hey,
that.
Danny, have a good night.
You too, man. Thanks for hosting. No, thanks for hosting so much. These
Yeah,
are great.
It was a pleasure.
No problem, man. It was a blast. You're always invited. All right. I'm sorry, guys. Go ahead.
All right, so
Thanks,
I would
Dan.
say
Good
that what
combo.
you're offering as the explanation that, hey, we have things that have multiple purposes, that's not really explaining the origin of each of those purposes, right? That presupposes that those, the armor and the wings, for example, on the ladybug, arose naturally on their own. Whereas I feel like I would argue that, hey, it's designed to have these wings and it's designed to have the armor simultaneously. And it might not be the best wing or the best armor, but in this hybrid state, it is the best. But I would say that that won't happen through natural selection. That will happen through design.
So, do you think that ladybugs and a fly are completely different kinds of animal? First of all, we can observe those changes with science. So, we did not see the mutation not in a lab to create a ladybug, but we have mutation on insects that can change wings and so on. So we know how these things works. I'm not a biologist, but I did um, I did some experiments on nematodes, not insects, of course. So I did see some mutation on how the works. Of course, I was in high school, so I did very little with that. I used electrophoresis machinery. I did observe some mutated nematodes, and that's all about it, more or less. But yeah, we know how mutation works. So yeah,
Right, but I'm not saying that it can't be modified. I'm saying that you're not getting the origin of something new using these processes. So you could have sort of an already armor-like wing structure become more armored or more flight, or more capable to fly. You can fine-tune it one way to the or the other. But if you just have an armor structure at the start, it's not going to become the wing structure because it's going to fine-tune to the armor structure. Whereas if you already have the armor structure and the wing structure, then it can keep either one of them and still develop the other. But that's only after you already have both of the structures in place.
But we kind of know that insects have the same structure, and they did share some kind of ancestor. So we know. I think I'm not an expert on that, but I think we even know what kind of mutation do causes these things. So we know how can we get to ladybug or a fly.
Right, but I'm saying from the perspective of natural selection, once you have an established purpose that helps the organism survive, and that's the purpose, it's going to further fine-tune towards that purpose rather than building a new purpose.
You can have a mutation that alter the organism in a good way, and you can start with that. And also you can have a split, so you can have a better ladybug with good armor and a different kind of ladybug with for wings. You can have both.
Is there a consensus in the room that I'm picking up
Okay,
that
I'm not
evolution
sure
is
I follow
actually
there though,
true?
because something like a wing would have
Hold
multiple
on,
separate parts that all need to
hold
function
on,
together.
hold on. Just a moment, just a moment. I was talking, thank you. Is there a consensus in the room that evolution is actually true?
To some degree, I think yes.
I think to some degree, no. I think not.
Depends what you call evolution. Hey, Happy New Year, guys.
Shalom, Daniel
Happy New Year,
Izvitsky.
Daniel.
Yeah, Happy New Year.
Shalom, Gavin. Shalom.
There's no
Shalom,
consensus for evolution. That's ridiculous. That's retarded.
Yo,
in this
Yo,
one,
I agree with
praise.
Godzilla Freak over here because I mean you're telling a story, Luca. Like we know that, we know that, we know this, but we could mutate flies, we can mutate ladybugs, we can mutate spiders, and it's not like they're gonna grow wings and start flying.
Yes,
Look,
they
look,
are.
look,
Yes, they
you
will.
mentioned, you mentioned you know a fair bit about insects. Can you tell us the evolutionary process of the caterpillar to the butterfly? How did that happen?
That's not evolution, you know, or that's right.
well, no, you would argue that
How
at some
did it
point the
happen,
creature did
Luca?
not have metamorphosis, and then at some later point it did, right?
do not know, but it's not evolution. The process of metamorphosis, it's not evolution. How did that process evolve? I do not know.
It's impossible. Tell me what a half. Tell me what a half butterfly, half caterpillar looks like.
You won't see one.
Thank you. Evolution is impossible.
What does it means? A butterfly, it's a lepidopter. Okay, so we have similar organisms, but what does even mean an half butterfly? Because the insect is the butterfly, and that's the insect. A caterpillar, it's a pupa, so it's a different stage. We have
thank you for making it impossible. Evolution is about the slow, gradual process of getting from one to another creature. So how did the butterfly get from a caterpillar? In slow, gradual.
You know that because it's metamorphosis, it's a change from a pupa to an adult form.
No, that's not
evolution.
George's argument, though.
No, you're just hand waving now. You're just hand waving.
All right, let me explain this. So, what George is saying is, how did the idea, sort of metamorphosis originate through evolution? Because the things before didn't use metamorphosis, and the things after did. So, what evolutionary process will make that a thing that happens?
Okay. I do not know. I know that there is an explanation, but I'm not an expert because I did study insects, but on my high school years, so I did not follow some college level classes. So,
well, Luca, what if you were to?
Yeah.
Well, what if you were to look up? Because you said there's an explanation. Let's say you did go look up.
I cannot right now, but
no, right. I'm just saying, hypothetically, when you go look up the explanation, I am going to predict that, as usual, it's nothing more than a just so story. Maybe this, maybe that, but yet not empirically observed or demonstrated. If that's the case, and that's what I'm predicting, Luca, would you admit that it's not empirical, the explanation for the evolution of
because we have similar insects. As I said, a butterfly is a lepidopter. So there are similar insects out there. If you have an insect with a similar process and another one with something in between and then a butterfly, you can guess what was the process that aroused those characteristics. Okay,
but there's not an in between, is there?
And you are sure about that?
Okay, no,
absolutely.
I just want to sort of further
so
clarify
you
my
did
point.
study this topic because
what's that?
Did you study this topic, metamorphosis in particular? So
exhaustively, and you are talking nonsense.
There is no in between. There is only the butterfly, because every insect has some form of pupa, not just the butterflies. And
it is extremely common knowledge that the fossil remains show no evidence of in-between evolution. The fossil remains show no evidence of in-between evolution.
Define in-between evolution, please.
No. Don't play silly games with me, boy.
It's not a silly game. I need to have a definition.
The fact is, boy, you're a lot younger than me. You're a lot younger than me. So listen, the fact is, the fossil remains show zero evidence.
Lineages.
Any kind of macro evolution. That's because the fossil records are so scattered and disordered. What you're talking about are just assumptions.
Hey,
Never
Captain,
proven.
easy on Luca. Take it easy, man. You're beating him up.
Right now,
That's all right. That's okay. Sometimes evolutionists need to be taken into the phone booth and mugged.
I know, but we like Luca because at least he's respectful.
Yeah. Okay, so like I think the important point to mention with what I'm arguing is that in my line of reasoning here, natural selection actually works against the creation of new structures, because anything that would be sort of halfway towards a new structure would be less functional than fully committed to the other. So let's take the ladybug example again. As it's
Correct.
evolving, if you have sort of armored half wings that are yet incapable of flight compared to one that's just armored, the one that's just armored is going to do better in the environment because it's more optimized. So the natural selection is actually going to take out the ones that are developing half a wing that are yet incapable of flight, and thus the wings will not be able to develop.
I can give you an example. Just think of some kind of biome or some kind of place where there are no threats to these ladybugs and they do not need armor, and some mutation happens and their wings became less and less tough. There would be a problem if some kind of predator was in the place, but there is none. So those ladybugs, they can fly better, even though it's not fully a wing, but maybe just because, if you know, the ladybug can still move those wings, so they can fly a little bit better. They can fly a little bit faster. And some other ladybugs, they are hunted, so they need better armor, and so they improve that trait. And that's how it works.
Yeah, but that's not science.
Right. So basically, you're saying that in a
you
favorable
can
enough
observe
environment.
those things
Okay, let me
right now.
So what you're saying is that if the environment is favorable enough that it's easy for it to survive, that even if it's suboptimal, right, it'll
Yeah.
still be able to proliferate and keep reproducing.
Yeah.
But the thing is, if there's not enough environmental pressure, then it's not going to further develop a new trait through selection. It's just going to be random. And we know from mutations, it's more likely to lose the half-built wing than to build it up even further.
We do not know. As I said, maybe those mutation can give an advantage on that place if you are not threatened to fly a little bit better. You can arrive faster in some location. You can find food more easily, and so on. There are different pressure in different places, and that's what's driving evolution. It's not always the same, and you can tell it because not all insects have two wings. Some have four, and it's how it works. Some are better flying, some have some kind of armor, and there are no better way to survive. There are various ways to do it. Some can be tough and have an armor. Some are faster, or they can blend with their environment better. And evolution can go in every way possible. there is no purpose behind it. It's just what.
Just because it has no purpose doesn't mean it can go any way possible.
Of course, an insect cannot become a monkey, but what I'm telling you, you can go in different direction. You can be tougher, you can be faster, you can blend with the environment, and so you will be not spotted and hidden. And there are different things. What's better? There is no real better or worse.
Right.
Well, I think that's the problem, Luke. I'll just say one thing, and then I'll let you guys continue. I think that's the problem. Is what I'm personally seeing is a lot of just so stories. Maybe this, maybe that, and then based on what you said, that organisms can become faster, stronger. That's why I typically point out that the evolutionists, they look to two different things. Okay, adaptation to environments. That's what you're talking about. That's what we all believe in. We see that. That's observable. And evolution of higher life forms. The evolutionists seem to treat those two things like they're the same thing. But it's clear that these are two very different issues because we agree on the adaptation part. And we've described how adaptation can be accomplished. But through these, like, for example, with the evolution of what we're talking about here, or the evolution of the development of higher life forms, this requires something on a whole nother level. And that's where I feel like the evolutionists failed, because now they are resorting to the storytelling. And that's where I am just simply just pointing out, is this empirical? Is this demonstrable? Is this observable? And I would say no, it's not.
It's also an example of a loss, not a gain. I mean, you don't know what that armor is for. The armor could be there to protect the wings, not to hinder the wings. So you don't know any of that information.
Yeah, so what I'd like to say, addressing that point, is that basically you have to say that having a half-developed wing structure is able to give a benefit that is greater than in some way, in some environment, that is greater than what any other structure is capable of. Because you're sort of investing into that structure, right? You're taking that on. And I would say that a half-developed wing is inefficient to the point where in any competitive environment, it will be selected against.
In a competitive one, but there are.
And in a non-competitive environment, there's not
Do
enough
you
pressure.
not have some problem? Just think about the dodo. It was pretty pretty a weak bird. We killed it just to eat it, and it was very easy to do so. But where he lived, he was doing fine, and that's what's affecting the various process.
Right, but
On what Standing was saying, it's the same process, because if you take an insect, give him a couple of wings and not 4, there is a very big difference from a fly to a butterfly. There are quite different structures. So yeah, that's evolution.
But Luca, how do you get from a caterpillar to the butterfly, something with no wings to something with wings in one generation?
Because it's not evolution, it's metamorphosis to a pupa to an adult form. It's a different thing. Every insect change
but
in
that
that way. If you
that
look,
would have had to develop through an evolutionary process.
yeah, but it's not like in one generation you have a caterpillar and then a butterfly. The butterfly will change generation after generation, and we have pupas in other insects, and they do not undergo um, metamorphosis. So we have different process to get to a pupa to an insect.
So it's a unique evolution. It's not
Good,
related to
good
anything.
morning, guys. Can I read a quote here quickly? And
Okay.
it is about overlapping codes. Our analysis confirms mathematically what would seem intuitively obvious. Multiple overlapping codes within the genome must radically change our expectations regarding the rate of beneficial mutations. As the number of overlapping codes increases, the rate of potential beneficial mutation decreases exponentially, quickly approaching to zero. Therefore, the new evidence for ubiquitous overlapping codes in higher genomes strongly indicates that beneficial mutations should be extremely rare. This evidence, combined with increasing evidence that biological systems are highly optimized, and evidence that only relatively high-impact beneficial mutations can be effectively amplified by natural selection, lead us to conclude that mutations which are both selectable and unambiguously beneficial must be vanishingly rare. This conclusion raises serious questions. How might such vanishingly rare beneficial mutations ever be sufficient for genome building? How might genetic degeneration ever be averted given the continuous accumulation of low-impact deleterious mutations? So there are overlapping genes, and this is very strong evidence that just mutations and natural selection is not the driving mechanism for complex organismal building. And I have investigated this topic over years, and my conclusion is that the gene-centric view is overturned by a more holistic view. And the big umbrella contributor to explain organismal complexity and biodiversity, which falsifies and replaces unguided evolutionary mechanisms, is pre-programmed, prescribed instructional complex information encoded through at least 31 variations of genetic codes, and I have listed so far 41 epigenetic codes. So complex communication networks use signaling that act on a structural level in an integrated, interlocked fashion, which is pre-programmed to direct growth and development, respond to nutrition demands and environmental cues, control reproduction, homeostasis, metabolism, defense systems, and cell death. And that unequivocally brings us to an intelligent designer, because this has to be an integrated systems where various codes work in an integrated fashion together, and it's not genetic information, it's also epigenetic information in special gene regulatory networks which orchestrate gene expression. And I am listing 19 different mechanisms which are involved in organismal development, and you can forget evolution. That is overturned. So who is still proposing evolution as a driving mechanism of organismal complexity is completely outdated.
At least you can't discuss it without addressing all those factors with every detail that you want to include.
Yeah, well, I have put here the link in the private chat and in the public chat, and you guys can look up all the mechanisms. I'm listing them.
Okay, Luca, I don't think that looking to a sort of non-competitive environment will help your case in the forming of a new structure. Because since it is true that, hey, like half the structure is suboptimal, you need an easygoing environment for it to further develop. But from our observations, we know that in an easygoing environment, things are not going to build new structures. That's just what we observe because there's not enough pressure causing them to do that.
Well, another death knell into evolution is the fact that an organism, even to start to be alive, has to be inbuilt the pre-programmed mechanisms to adapt to the environment. And if it doesn't have that, then it would suddenly die. So evolution or adaptation or microevolution, this is a pre-programmed process which has to be already there when life started.
Right, like there's a reason that Lenski, when doing his E. coli experiment, he didn't put them in a favorable position and wait for mutations to build up beneficially, because that wouldn't happen. He has to sort of force them into abnormal environments in order to cause adaptation, because that's how natural selection would act on it.
Well, one thing is clear, that natural selection and mutations are an entirely inadequate explanation of organismal complexity and biodiversity.
I can give an answer to Godzilla. Yeah, you are right. Just think about it. You can have no predators at all, but you can have food shortages. So you need to be faster in that environment. You still have pressure, but it's not from another insect or a bird or anything like that want to eat you. So that's what's causing this change in this hypothetical scenario.
Right, but I'm not saying that.
So on Tangela, you're saying that external pressures really don't amount to anything compared to the internal complexity.
Right, no, let's say we have the external pressure of needing to be faster in this environment.
And in order to have the complex forms of multicellular organisms, you need to specify each single cell in regards of many different aspects. I can put the link here too. I can quickly list them. Explaining organismal form depends on explaining how organs, tissues, and cells form and gain shape. On the lowest level of the hierarchy, the formation of cells in a multicellular organism depends on the specification of morphogenesis of various eukaryotic cells, structures, and shapes, cell fate determination and differentiation, the phenotype of what cell type each one will become, then the cell growth and size, development, and cell division counting. Cells need to be programmed to stop self-replicating after the right number of cell divisions. Then mechanisms of pattern formation, Hox genes, position and place in the body, this is crucial. Limbs like legs, fins, eyes, etc. must all be placed at the right place. And then what communication it requires to communicate with other cells, and the setup of the communication channels, then sensory and stimuli functions of cells. What specific new regulatory functions do cells have to acquire? Then when will the development program of the organism express the genes to grow the new cells during development? And I have 17 different issues which have to be specified in regards of each single cell. Now, think about that. The human body has 37 trillion cells, and each one of them has to be specified in regards of all these points which I mentioned. And the genome of the human body with 3 billion nucleotides has absolutely not the sufficient information to specify all that kind of information required. So there is evidently epigenetic information in a hugely larger number in play, and a huge amount of data which specifies all that complexity.
So it's like biology is a cryptocurrency. Any change in the blockchain has to take into consideration the whole chain itself.
I am listening now, and this number has just growing. 41 different epigenetic languages and codes, which are all involved in organismal building. So Genetic information is just one tiny part of the complexity.
Right. So I just want to get back to my point there, where it doesn't have to be a predator being the external pressure. Let's say the external pressure was something that forced you to be really fast. Well, having half a wing wouldn't really make you fast, at least not compared to, say, an adaptation of the legs, which lets you run faster. So it still gets you to the problem where the half the wing, sure, you might be able to get there. There might be sort of these intermediary steps from these little wing parts to the wing, but there is not an environment where they're beneficial enough to be selected for.
Just think about it. Ladybugs can fly already. Even with malformed wing, if the weight is less and you can move it with ease, more ease than the actual armor that the ladybug has now, you can move better with that. Okay,
Right, but
even
getting
if
lighter is
it's not
structure.
already a wing, but you can move better because it's easier to move it. It's weight less, and you can fly better.
But in order to have flight,
you
you
can
need to morph the entire organism. But let's suppose that you want to grow a new limb. Okay, and I'll read here. In order for a new limb to evolve, let's say arms, not only would have there to be new information of where to locate the new limb in the body to be functional, and that is performed by Hox genes, and developing the right sequence and order, but also at the same time, each of the 7 mentioned items which I'm mentioning now would have to develop together, and that makes it an irreducibly complex system. That is first the muscular system, the skeletal system, the nervous system, the endocrine system, the circulatory system, the integumentary system, and the lymphatic system. That are 7 different systems that you have to grow together. You cannot grow just one of these.
Right, Luca. Now, what you said there about the ladybug losing weight in order to go faster, that's actually illustrating my point. That would be something that would happen in one step, really, with natural selection. That's like one mutation. It loses some armor, gets lighter, and that will, in the right environment, then be selected for over a mutation that's halfway towards building another structure. So that's the easier adaptation to make, and that in a harsh environment, evolution will make the easier adaptations, and in a non-harsh environment, it's just not going to really change.
Yeah, but with those conditions, you will have in some time a ladybug with 4 wings. On Otangel's point, you do know that we observe organism with more legs. Just think about us. There is a mutation that can give you an additional finger, and it's even selected for if you it's dominant. So mutation do not work as you are saying. You can have a single mutation that can give you an additional finger. In cats, I think that you can get a cat with 7 fingers. I think even 9.
Right, but with the case of fingers, we know that the genetic information to make a finger, including all of its internal components, is in the genome. So it's really just like the number that the body will grow that's changing. It's not a new limb that's distinct, right? It's another copy of an existing limb.
Yeah, Godzilla. So you can have the same kind of mutation and have an additional leg in a fly. I think they had this experiment with the fruit flies that grows additional limbs. And if you succeed to select this mutation, you can have very different organisms with more legs and so on. And that's how evolution works. Because you can say it's only adaptation, but if you will end with a ladybug with 4 wings, it's not really a ladybug anymore. You need to call that a ladybug because their ancestors were ladybugs. So for cladistics, you will call that a ladybug. But you and me, if you look to an insect with 4 wings, you will never call it a ladybug. Okay.
Well, no, I would actually disagree with you there because if you look deeper into the genetic material, it's a very small change, really. It's like it's still significant, but it's not a huge change to go from 2 wings to 4 wings because really it's a regulatory change. It's the gene that controls how many wings are being grown. It's not even anything to do with the genes of the wing itself. It's just the controlling of how many wings are being grown. And while morphologically that's a big difference, genetically that's actually a small difference.
Well, the thing is that you need to locate the new limb at the right place. And that is done through development programs, which are extremely complex.
Right,
And
that's not adding any new, any really novel information at all. It's just changing a number almost.
well, the thing is that everything that has to do in regards of development has to do with information and very precise information on various levels. And it's special with signaling, like morphogens, which are signaling molecules. They direct the cells where they have to concentrate and where they have to grow a new limb. And that's all based on specified complex information. That kind of information that isn't simply happenstance. That is something that has to be prescribed and pre-programmed. And that's why we propose an intelligent designer.
That leg on the fruit fly, by the way, grew on its head at the expense of the antenna, and the four wings on the fruit fly were useless because it couldn't fly. So I don't know how natural selection was going to improve on that.
But you add some additional legs or not. It's all the point. It's not that easy because you cannot say you can add wings as you want, because if you think about it, all insects have 4 wings. It's not that easy to modify that trait. I do not know why. I'm not familiar with the genome of insect in general, but it's quite a difficult trait to modify. You never see insect with 8 wings. Even the flies and mosquitoes that you can tell have only 2 wings, kinda, because they have the other 2 wings. There are just different structures. So there are some changes that you cannot made like that, but it's possible to grow an additional finger or a leg in some instance. It's not that easy, and you need someone with expertise in that field to explain why. Because I do not know. I just know that, for example, wings are not so easy to lose because all insects have 4. Some they add modification with those wings, but all of them have 4. And to lose it, just think about ants. You need to scrap more or less half of the genome of the creature.
Okay, what
Right, I
directs
was thinking
the organism structure are Hox genes. Now, the problem with that is that many biologists, they forget that when invoking Hox genes mutations, that Hox genes can only rearrange parts which are already there. They cannot create truly novel structures. So you have to account for an entirely new structure, and you'll not get that with Hox genes. And as I said, there are many different epigenetic information systems involved in making new limbs, and many systems, they are irreducible. They have to be grow together in order to have a new limb, and that requires a large set of orchestration of information. That kind of information doesn't simply happen by happenstance and mutations in natural selection. It's simply not true that genetic information alone is sufficient. It's not. And when you expand it, which is being done even by evolutionary proposals, into epigenetic information, and you start to understand that this information has to be orchestrated and is integrated. One kind of epigenetic information interacts and dialogues with another kind of epigenetic information system. Then you have to ask yourself, how can that kind of complexity and sophistication of information emerge by unguided events? That simply makes no sense.
If I could make one point, actually, and then and Luca, since you're the atheist guest here, take as much time as you want. Just to make it simple, in kind of the form of an analogy, what's an extra limb or an extra arm, an extra leg? What is that really going to do? Because if I gave you, let's say, Luca, I gave you a copy of a book that you already own. Actually, let's say I gave you 10 copies of a book that you already own. You have nothing novel and meaningful, kind of as Godzilla Freak was saying. And even if you wanted to go down the route that the evolutionists do, when you duplicate something on a genomic level, they'll look to neo-functionalization, where enter mutations will change that gene, which will in turn change the phenotype of the organism for the better. But here's the thing, you start introducing mutations, alterations in the genetic sequence, which we know, based on what Otangelo was saying earlier, these multiple overlapping codes, it's only going to make the organism worse, right? Because it's only going to lead to further degeneration. So I think the important point to be made is there anything novel? Is there anything meaningful in these types of changes?
They bring up very often the chimp and human similarity of the genetic information, and say it's 98% similar. But if you look at the morphology of chimps, it is very different. If you take any of the bones of a chimp and compare it to a human bone, you will see that each single bone of a chimp has a different size and morphology than a human bone. And you have to have the specification of all that difference. And it's evident that if the genetic information of chimps and humans is 98% similar, then there has to be other kind of information which specifies that differentiation and difference. And of course, that is epigenetic information which is doing that.
Okay, Standing, just think about it. Novel structure, like the ladybug has a shield-like structure with two of its wing. It's the same thing. It's a novel structure, because if you have those changes, you can trace it and say, yeah, those are wings, just they are tougher and they cannot be used anymore to fly, but they just protect the insect. But just think of these kind of changes, one over another, and you get a very different organism. If you look to a ladybug and a fly, or a ladybug and an ant, or a ladybug and a butterfly or any kind of insect, you can see how different they are. But we are agreeing that they have some kind of ancestor, those things. So
I think that's where your assumption that the
yeah, I think that's
fly, the ladybug, the butterfly would be related, because what I'm seeing here, and then I'll yield the mic to somebody else, is typically what I see that the evolutionists, they hope, dream, and imagine that these changes, let's say mutations, okay, which lead to the novel genetic variation for selection to act on, they imagine that these add up enough, all these small scale variations, like you're saying, right? You're saying just picture enough of these, and then the story comes in. Enough of these will eventually add up to make something, but that something is something we don't actually observe. And then based on what you're saying, look at the ladybug, look at the ant, look at the butterfly. I think that's making a lot of basic evolutionary assumptions that they're even related in the first place. But then you have to overcome everything that Brother Otangelo was talking about, in the fact that this type of goo to you evolution, fish to fisherman evolution, it has to explain how the 4-dimensional genome with multiple overlapping codes, in that paper that Otangelo was citing, I reference it in my new book, Special Creation, because it just shows what a ripple effect even one single change, let's say a point mutation, a single change in a nucleotide, a huge ripple effect just from that, and not for the better either. So evolution has to explain the evolution of these multiple overlapping codes that are nested and chock full of meta information. How did all this come about? And then explaining how this all came about, while also overcoming the fact that mutations degenerate and put shelf lives on genomes. So it's like problem after problem after problem. I know that was a mouthful, so I'll yield, give Luca a chance to respond, and then
I have a question. On your model, what kind of insects are related one to another? Just to understand. For you, a fly and mosquitoes are related, and they are related to a butterfly.
Yeah, I would say a mosquito and a butterfly are not related.
Okay, but a mosquito and a fly?
I would say a mosquito and a fly are not related.
Really? Because
Mosquitoes
you
and
know
flies
that are pretty close. A mosquito and a butterfly, they are quite different. A mosquito and a fly, not so much.
Right, and that's a good point.
A problem which I see still today is that many proponents of evolution, they want to do the phylogenetic comparisons. And in my understanding, this is a completely inadequate approach to try to substantiate biodiversity, because we have to look into the biomolecular level to understand what actually are the mechanisms which promote biocomplexity and form. And when you do that, then you understand that it's not the section of the genome which codes for proteins which is relevant to make organismal form. It is the part which is not coding for proteins. And in special, what is in play is the gene regulatory network, which directs the orchestration of gene expression. And Davidson, which was a pioneer in exploring and investigating that, he said something very relevant. He said, no sub-circuit functions are redundant with another. And that is why there is always an observable consequence if a gene regulatory network sub-circuit is interrupted. Since these consequences are always catastrophically bad, flexibility is minimal. And since the sub-circuits are all interconnected, the whole network partakes of the quality that there is only one way for things to work. And indeed, the embryos of each species develop in only one way. So that means if you interrupt the gene regulatory network, then you have a catastrophic consequence. You cannot just simply change it and then go to a different body plan. That doesn't work.
It seems to me that Luca is talking in a typical primitive fashion that evolutionists employ that is completely out of date, considering the current science. It's irrelevant, your explanations. They do not apply to what we know today concerning biology. They're just wishful thinking to think that you can talk at that reduced complexity, which is a product of the past, and not consider the new complexity that science has discovered.
You know,
I'm curious. I'm curious to find out how a mosquito and a fly are similar.
they're quite similar, are the same. I do not remember it's an order or not. Are
Luca, is the eye of the octopus and our eye similar?
For what I remember, there are some key difference.
Yes, but in the overall structure, is it similar?
Yeah, kinda, but there are inverted something, if I remember correctly, and those eyes do not have the same. There are. I do not know about. I cannot answer.
Well, we are talking about the camera eye, and the camera eye is very similar in structure. Or I can give you another example, like echolocation of bats and dolphins and whales. Echolocation works, and there is even some blind people, human people, which can echolocate. So that is very similar, but we are talking here about organisms which are very distant one from each other.
Wait, are there actually people with echolocation? Like, can you learn that?
My point on convergent evolution, I was talking about it with standing. I think some hours into the stream that you can tell the difference. Like the wings, they still can fly with 4 types of wings, but they are completely different. One use a finger, one use an entire hand, another use fused fingers in birds, and you can tell the difference. I do not
Well, the
know
bat wing and
about
turd
these
wing are
things,
actually quite
but
similar.
you can tell in general when something is evolved from an ancestor or with convergent evolution, because you will have similar structure, but structure that will not follow like wings with the entire hand or just one finger, or with a false structure like for birds, and you can tell that are different. They are not the same thing, even though they do the same thing. It's also it's quite hard to argue to the biological chemical level to full-blown organism, and in one stream in particular. Reality it's really complex,
Yeah.
so you
I
need.
think that is absolutely correct. We are always underestimating the complexity of life.
Well,
Always.
I'm a chemist, so I do not. I know what complex is. Just think about chemistry in general. You do not need to look at living things to observe very complex compounds. Just think about crystal in general. Anyone that knows a little about it knows how hard it is to understand these things. My in my my course at university, there were two classes, very hard ones. No one can pass those things. One was about thermodynamics and so on, and the second one was about inorganic chemistry, just to give you an idea about how complex it is in organic chemistry. You do not need to get to life to have very complex things. So
No, you don't. It just seems that that fact escapes the way you explain some of your morphology. It
Right,
doesn't.
and it's not just the complexity, it's the complexity leading to a function. That's what's important.
That's a very relevant point which you just mentioned. You need foresight to make an organ, because an organ like a heart only works when it's completed. And of course, the question of irreducible complexity and interdependency, that extends all along and all over in biology. And it is not enough appreciated how big that problem is for proponents of evolution.
And the other thing, Otangelo, a heart without veins, without blood, and without nerves does nothing.
That's what I just mentioned. Whatever you propose, like an arm or an eye or ears or whatever, it is always something which is integrated and requires different parts which interact and work in an integrated fashion together. And the single parts by themselves, they have no function. If you take, for example, the movement of the human eye, which requires a system of muscles. These muscles, they need several things in order to move the eye. They need the muscle, they need the blood supply, they need the nerve, they need to be attached at the right place, and so on. These are integrated things which work together, and they have to be created together. By a stepwise fashion. To have just a muscle, that doesn't make anything. Just the blood supply by itself doesn't make anything. These are integrated systems which work like a machine, where you do not have a function of a machine unless you have all the sub parts working together in an integrated fashion.
It has to happen to multiple organisms so it could dominate the population. If it happens in one organism, maybe there's a slim chance it's going to proliferate over the entire population, but let's be real, it's unlikely. You know what I mean?
Yeah.
Like, the odds of these things are just so astronomical. It's like ridiculous. It's wishful thinking.
It's not. Just think about it. We have organisms without heart, without those structure you mentioned, and we have all the different intermediaries to one point to another.
Okay, Luca, let's suppose you want to go from a unicellular organism to a multicellular organism. You need two things which are essential. That is the mechanisms which stick the cells together. That is like there are 4 categories, and you need signaling communication between these two. If you don't have both at the same time, you cannot go from a single cell to multicellularity. So you need to specify both the proteins which stick the cells together and the signaling pathways where they are starting to interact and communicate with each other. So you have there already an irreducible and interdependent system, which cannot evolve by gradually, where you make first just the proteins where the cells stick together, then you have no communication. And if you have no communication, you cannot have multicellularity.
Except it was done in a lab setting to obtain multicellularity. So
yeah, Volvox, that is not a good example because they have all the genes already with the information to be both, to be multicellular and to be single cellular. Volvox is not a good example.
We did it at least a couple of times and with different mechanisms. And I'm taking, because of course I did not prepare for this exchange. I just woke up, made a shower, and open on the stream. So it's not like I can give you sources for this, but I do remember Dan from Creation Myths giving those examples, and they were done. I looked into it, and they did achieve multicellularity, and was even something that was passed on the next generations.
Well, I can read here, furthermore, cell adhesion is coordinated with other major processes, including cell signaling, cell movement, cell proliferation, and cell survival. And we now know that cell-cell adhesion receptors fall into a relatively small number of classes, and you have to account for all that complexity and the increase of that kind of complexity.
But if we can do it in a lab, even though, and I'm not an expert on the subject, so I cannot explain to you every single step of the process, but if we can do it in a lab, you will agree that, and it was done, that it's possible, even if, and I think we can explain it, but I cannot. So would you agree that it's possible to do so, to go to a multicellular organism from a unicellular one? Because we did it, and when we did it, even though maybe we cannot tell right now every step of the process, because science is not that simple. Just think about chemistry. We do not know everything about chemistry, not at all. But if you have an experiment and you can do it more than one time, and you know how to reproduce that experiment.
Well, I can repeat here. To go from a unicellular to multicellular organisms requires the emergence of several novel biochemical systems. And such systems include pathways that transform cells from generalized to specialized forms during growth and development, then mechanisms for the migration of cells relative to each other during growth and development, then structures that support cell-cell adhesions, then mechanisms for cell-cell communication, and all of these systems have to be in place and operate in an integrated fashion to support multicellularity. And to tell me that you can have that transition by unguided, non-intelligent mechanisms, that is, in my understanding, simply not supported.
Well, a single cell organism is quite complex by itself. So to go to multicellularity, you will just build on that complexity.
You need all these innovations which I just mentioned, and
yeah, we did it, so it's possible. Even though it's hard to do, it's very complex.
Okay, just say we did it, and you don't explain what was involved. That is simply superficial and is not convincing.
What is this organism called?
I cannot remember. I can tell you that was Dan Cardinal, who gave that example in a debate with Standing. And
I heard
I
one
would
word
love
Standing.
into
I thought
it,
they
but
only debated
of
the
course I
animals.
cannot tell the name of the
Okay.
experiment now.
And,
It's
and I
not
think Jeremy has made a very important point. All these labs, they are guided and directed by the experimenters. That is not what we simply observe in nature naturally to happen.
They just take one organism and introduce that organism into an environment with some kind of predator, some kind of organism that hunts unicellular organism. So
Okay, Guy, I'm leaving the stream.
yeah,
It was a nice chat here.
nice to see you, Angelo. Arrivederci. È stato un piacere.
Yeah, arrivederci. See you next time. Bye-bye.
Bye.
Hey, Luca, it seems to me like I realize that you could tell all these stories that, maybe this happened, maybe that happened, maybe the environment did this and then that. But when we look at nature, we don't see this evolutionary progress like you're talking about. We have bacteria and they just stay bacteria. We have, you know what I mean? We don't see them building up like, these stories you're telling, like them growing extra legs and wings and this and that. We just don't see it.
Well, I heard Lucas say just think at least 4 times since I've joined the stream again. Just think.
I mean, it's not. How is that science, though? It's just like I could tell a story.
That's correct. That's what I was about to say. It's not science. Just think is not science.
You know, right?
Oh, by the way, has anyone ever seen what sardines do when they're approached by a predator? They colonize. They colonize together in a group.
Yeah, see, all bait fish kind of do that.
Yeah, but I'm just using that analogy where Luca was saying when they introduced the predator of these unicellular organisms and they congregated together, that's just created a colony of unicellular organisms into one, they say, multicellular.
I believe the example that he's trying to give has something to do with that one organism ate another organism, and somehow the organism that it ate, somehow they both reproduce basically inside one another. I'm assuming.
No, Daniel. I've read the report. It's a number of unicellular organisms. When they introduced a predator, they actually colonized or grouped together to become one. It wasn't one eating the other.
Oh, I thought it was some kind of crazy endosymbiosis or something. Oh, well then, yeah.
It's possible, and it's even proven in the lab, but it's a different thing. So I need to go. I just have some minutes to spare, but do you realize that for everything I talk about this night, there is an entire field of study, and I cannot talk about these things because I'm not an expert on anything, because my field is chemistry, but I'm just a bachelor. I'm not even a PhD or something. You need to talk for every topic with an expert, and I know it's a lot. Let's be real. No human being can know everything about science, and we do not know a fair share of things, even though no one can know almost anything about science. You need to specialize to study just one subject. Even in chemistry, an organic chemistry and an inorganic one, There are completely different things. My boss, when I undergo my thesis, it was all about inorganic chemistry, and he didn't know anything about what I was doing, and he was a PhD professor, and I was the one knowing what I was doing. He was literally, I do want. I'm not saying he was stupid, but he was simply unaware about my field. He was not even able to use the machinery that I was using. Just
I kind of think that's the problem. Like all the examples Tangelo gives with all these systems built into these organisms, which is more like chemistry, right? All these interdependent systems, and then you got like a evolutionary.
And if you look even deeper, it's physics.
Yeah. So then you have that, and then you have evolutionary biologists that aren't really involved with knowing all these systems. How could one become the other? Everything involved. So they're telling these stories, but the actual probability of these things
Not
happening.
stories. The problem is there is an entire multitude of fields behind those things, and you cannot study them all. But well, you can understand a little, but you need to simplify it to a point. I can go to an expert of a field if I have a doubt or a problem with some part of the model, and that's all you can do. You cannot learn everything. If you go to molecules, to macro organism, you cannot do it in any time. It's impossible, literally. There are the explanations, but to explain how to get to, I say, from an amoeba to amoeba or are already evolved organisms. So not an amoeba, but an organism with one cell to a cat. You can understand that there is anything in between, anything. You will not be able to go.
Guys, before my battery cuts out, I just wanted to bring out one point what Danny was talking about. He was claiming that he was an atheist, but at the same time he was saying you cannot prove or disprove God. By his own logic, at best he should be an agnostic, not an atheist. So I don't know what kind of philosophical argument he's using there when he himself is actually disproving his atheism.
Oh, Danny?
To ask him.
Yeah, his argument is nonsensical anyway for the non-existence of God. With the a mind can't has to be able to fail. Like what? That's his own made up jargon. Like if I never failed, would I still not be a person? Like his argument doesn't work.
I do think that he was so over us. I was not able to follow him completely. I think it's very smart, and he knows what he's talking about. So I cannot say anything about it. I think his arguments were quite good, and I cannot understand them, not completely at least. So I need to go. It was really a pleasure to be here. Thanks, Standing, to let me here.
No problem. Yeah, Luca, I just wanted to jump in real quick before you go.
Yeah.
I think I'm going to perfect timing. We just hit the 5.5 hour mark, and it is time for me to also get some sleep before I fall asleep here. And Luca, you are always welcome on the channel. Very cordial, respectful, as always.
Yeah, boy. Yeah, boy.
yeah, even if it maybe gets a little heated here and there, but it was a good stream. 5.5 hours. I hope everybody in the chat enjoyed. I mean, we're still at 23 to 25 people. So one day we will just have SFT live for 24 hours. Let's say when we hit that 3K subscribers. So hopefully soon. Luca, you're always welcome on the channel. Maybe one night we'll just have you and I. We can have a discussion on kinds or something because you're always enjoyable to talk to. Yeah, I think that'd be fun. So, and Daniel, I know you joined us a little bit late, but thanks for joining us nonetheless. And everybody to the audience, God bless. And we'll see you Tuesday with Kent. He'll be here. So bring your questions. Luca, Daniel, have a good night, guys.
God bless. God bless.